this course will be about front-end bundler of new generation called Vite, and because of that it provides much faster developer experience compared to traditional front-end bundlers such as Webpack. So in this course we're going to review most of the Vite features, and we'll be doing it step by step to better understand how Vite works, which will allow us to use this tool more efficiently. So let's get started and install Vite locally. For this I'm gonna use package manager called npm. So let's copy this command and run it in a terminal. This will prompt us to enter project name. Then we're presented with option to choose which framework we'd like to use. We're not going to use any specific framework, but instead we'll review Vite features by using vanilla JavaScript. Then it will ask us if we'd like to use TypeScript. We will definitely have a lesson about how to use TypeScript in Vite projects, but most part of the course will be using vanilla JavaScript. And at the end we'll see 3 commands that we need to run sequentially in order to run Vite server. Firstly, let's go inside of project folder. In here, let's run npm install to install all npm dependencies. And finally, we can start Vite server by running npm run dev. Here we will see which address we can use to access our project in the browser. So let's open up a new tab. And here we see welcome screen of the default Vite project. Then let's open up project inside of editor. I'm going to use VS Code. And just to make it easier for us to learn how Vite works, we're going to install a helpful Vite plugin called Vite plugin inspect, which will allow us to see how Vite transforms our source files. So we will get access to such dashboard in the browser, and all transformations that Vite will make with our source files will be visible to us at every step of transformations. This plugin can be installed by running the following npm command in the terminal. So let's run it and wait until installation is finished. And just to let Vite know about this plugin, we need to add the following instructions inside of Vite configuration file. Firstly, we have to create this file in the project root, unless it is already created, and paste in here all those instructions that we just copied. And then we're given with address which we can open up in the browser, where our installed inspector will be available. But for now it is not accessible yet. We need to restart our Vite server. Let's go back to terminal, stop development server by pressing Ctrl+C, then run it again with the command npm run dev. And besides Vite server's address, we also see another address where our inspector will be available. And we'll see this screen that means our inspector has been successfully installed. What it is and how to use it, we will be talking about in the next lessons. And for now, let's see which file gets loaded in the browser when we access root of our Vite server. And the file which is loaded is called index.html, which is in the project root. Here we can see that this page also includes main JavaScript file, which by the way is included as native ECMAScript module, because here we can see attribute type with value module. And all our application gets mounted into this div with an ID of app. So now let's open up main JavaScript file and see what is happening inside. And right away we can see unusual imports of CSS file and SVG files, which are not supported natively in browsers. So if we would be using normal static server, those imports would fail. But Vite treats those imports in a special way. And before serving those imports to the browser, it applies all necessary transformations to make browsers to recognize such imports. We're going to talk about it in details in upcoming lessons. But basically, whenever we import CSS files like this, Vite is going to inject all these styles onto the page. And whenever we import assets such as SVG images, Vite is going to export path to this file and save it in JavaScript logo variable. So then this path can be used in a normal way, for example, inside of source attribute, as we can see right here, to reference corresponding image. And sure enough, this image will be visible on the page. It is this JavaScript logo. The same thing happens when we import vite.svg file, but there is one important difference. You may notice that vite.svg file is not in our project root. It is actually inside of a special folder with the name public. And for Vite, this public folder stores all static assets. And all static assets that are stored in this public folder will not be processed by Vite, but instead will be returned to the browser in its original form. We're also going to talk about this folder in detail in upcoming lessons. And finally, the last import we can see right here is normal import of ECMAScript module. It is this counter.js file, which provides functionality for the counter whenever we click on that button on the page. And we see that the counter increases with every click. But we are going to start our explanation of Vite from the very beginning. So let's clear everything inside of main.js file. Let's also remove counter.js module, which we will no longer use. And finally, we'll remove all default styles inside of style.css. And now we're done with installation and initial setup. From the next lesson, we're gonna start reviewing Vite's features step by step. When we install Vite project, there are 3 pre-configured commands inside of package.json. First command starts local development server. We have already used this command in the previous lesson, when we started dev server by running npm run dev. The second script build is going to build our project for production by applying all necessary optimizations to achieve better performance. And there is also one more script, preview, which starts basic static web server to serve our build application to see how it is going to behave in the production-like environment. All these 3 scripts use Vite binary, which we get by installing Vite npm package. And this binary is contained within bin folder, which is inside of node modules folder. So when we use Vite commands, everything starts with this script. So let's start reviewing Vite's features, switch over to the terminal, and start development server by using command npm run dev. In the previous lesson, we have removed everything inside of our main JavaScript file, so we see a blank page in the browser. So let's go inside of index.html and remove this div with an ID of up. And on this place, let's add a heading with some text. Right away, these changes will be reflected in the browser without manually refreshing the page. And since our main script file is included as ES module in here by using this type attribute, we can of course use import and export keywords to include other modules. And browsers will properly fetch those modules. So let's try to import in here arbitrary JavaScript file. We're going to create this file in project's root. And here we'll just use arbitrary console.log statement. And let's see what's gonna happen in the browser. When our main application script is requested by the browser gets content of this script. And once it sees this import, it is going to fire an extra request to the server to fetch this module. This is native ECMAScript feature, which is currently widely supported in all modern browsers. So we can easily leverage native ES modules. And once we get a response on request to fetch module with name A, we get this content and browser is supposed to run this module. So now we're supposed to see this console.log statement in browser's console. And sure enough, we see this output in here. So by now there is nothing special going on. And such imports of ES modules are natively supported in browsers. So let's try something more interesting. For example, let's try to use npm package. To demonstrate this example, I'll be using a library called collect.js. Let's go ahead and install this library by using the following npm command. And once this library is installed, let's go back to docs. And here we just need to include this library on the page. So let's use this import statement in our main script. We'll add it here right after our import of the first module. And then let's try to use this library, for example, to calculate average. From the docs, we're gonna copy over this instruction and output result in a console. And now let's see if it's gonna work in the browser. And if we would be using normal static web server, imports from node modules folder will not be recognized. So import of this collect library is not going to work. But in our case, we're using Vite server, so this example worked fine. And we got calculated average in a console. And let's find out what happened in this case and how Vite was able to process our import of npm package. So whenever we requested our main.js file, we can see that Vite has done some processing and it transformed the second import when we try to import module from node modules folder. Let's take a closer look at this import. We see that Vite transformed path to this library. And once browser receives this transformed import, it is going to request this library by using the following paths: node modules.vite, deps, and the name of our library collect.js. And once browser tries to request this file by using the following paths, sure enough it gets source code, which makes that collect library work in the browser. So Vite has dynamically generated folder called Vite within node modules folder, and here it puts source code of our imported library collect.js. And at the same time, Vite has done some optimizations to this source code. And this is how Vite makes it possible to import libraries directly from node modules folder. So these libraries will be available to use inside of browsers. And this is a big advantage of Vite server over basic static server, since static server cannot resolve imports from node modules folder. And now let's take a closer look at what transformations are applied to our source files when they are served. And exactly for this purpose, we have previously installed Vite plugin called Inspect. Here we can clearly see how Vite transforms our source files. If we select here module main, we can see initial content of this module as we wrote it, and transformed code, which gets sent to the browser whenever browser requests this module. Here we also see that import of module from node modules folder. But if we take a look at transformations what are being applied to another module, a.js, we can see that the content of this module is left as is. So we didn't try to apply any transformations, because this content can be easily recognized by browsers. So no extra transformations are needed in this case. It's just a simple console log statement. Now let's go back to the editor, and in projects root, let's create new folder called source. This is pretty common convention to name this folder source, which is going to store all our source files. And right away, let's just move our module A inside of this folder. And right after that, let's go to main.js. Here we'll fix the import to import the module with a new name, and move these two lines with usage of collect.js library into file to.js, so that the module's file name corresponds to current lesson number. And one more time, let's see what's going on in the browser. When browser requests our main script file with the name main.js, it parses content of this file, and once it sees this import, it is going to fire another request to the server to fetch module with this name. And we see this request right here. And while fetching content of this file, Vite has done extra transformations to provide support for importing modules directly from node modules folder by doing all necessary transformations to this import statement. And here you may have also noticed that we were able to use collect library by using name collect. But here we import this library under randomly generated name. And if we search for this name in this file, we can see that it gets assigned to the constant with name collect, which lets us use this library in a usual way. And finally, once browser has fetched source code of collect library, we were able to easily use functionality provided by this library. And the ability to use libraries imported directly from node modules folder is a great advantage of Vite server over basic static server. Let's take a look how we can work with CSS files in Vite projects. Right now there is no styles applied to our page, so let's go to main JavaScript file and try to import CSS file that we're going to create. We're gonna call a new file 3.css and place it inside of source assets folder. And here we'll just add some basic styles to see that our CSS will be applied. We're gonna make background color of body dark gray and text color white. And so let's see what Vite is going to do whenever it sees that we import CSS file. As we can see, styles have been applied right away to our page. And here is how it works. Whenever browser makes a request to fetch this CSS file, Vite is going to process this CSS file and generate valid ECMAScript module that looks like this. So by doing the request to fetch that CSS file, we got valid ECMAScript module in a browser, and this code contains instructions to inject our CSS code onto the page. We also may notice in here that all those styles from CSS file have been assigned to the constant vitejs in the form of string. And then this string has been added to the style tag inside of the head element. So let's take a closer look at what kind of transformations are being applied whenever we import CSS file. Let's open up our inspector, and whenever we request CSS file from Vite server, it basically makes this transformation of CSS code into valid ECMAScript module. And this is how Vite makes it possible to directly import CSS files as valid ECMAScript modules. And here is one more way we can import CSS files. So by adding query parameter called inline to this import, we can get the content of this CSS file as a string into styles variable. And then let's see what is contained within this variable by printing it in a console. And when browser fetches our main JavaScript file, it sees this import, so it makes another request to the server to fetch CSS file. But Vite also sees that this request has query parameter called inline, and this is kind of a sign to Vite that instead of automatically injecting CSS styles onto the page, it should directly return content of this CSS file as a string. So in response, it's gonna generate a valid ECMAScript module where standard export will be exporting all the styles from the imported CSS module. And if we'll take a look at the console, sure enough, we're gonna see those styles as a string. So this is how Vite processes CSS files, and this is what transformation is gonna be applied in this case. Whole CSS code will be converted to a string, and this string will be exported as a default export from the generated ECMAScript module. And then in our JavaScript code we can do with those styles anything we want. For example, let's create new element style. Let's assign those styles to inner text property, and then we're going to find the head element and append our newly created style element to the head. And this way we're gonna end up with the same result as if we would import CSS file in a normal way without using inline query parameter. As we can see, we just manually injected those styles inside of head element. Formatting of style tag will be a little bit different in here, but the end result will be the same. And this is how Vite handles CSS imports. Let's go back to main.js file, remove everything from here, and leave only import of CSS file. We're gonna continue working with CSS in Vite projects in the next lesson. Let's see how we can work with CSS module specification in Vite projects. First of all, we're gonna import a couple of CSS files in our main script. Let's just give them arbitrary names and create these files. As with another CSS file, we're gonna place new files within assets folder. And now, just to have something to work with, let's add here some CSS rules. For example, we will have heading class, which will have the following rule. Color of the text will be orange. And in another CSS file, we're going to have the same CSS selector, but in this case, let's use another CSS property font size and set it to 30 pixels. And so what will happen right now when we're gonna use this heading class is that it's going to apply both of these rules to the element. So the color will become orange and font size will be 30 pixels. Let's just assign this class heading to this h1 element. And before we check it out in the browser, let's go back to main.js file and import another CSS file, tree.css. This is the file we have already created in the previous lesson. And we already know what will happen in a browser when it's gonna make requests to fetch these CSS files. Actually, Vite is going to convert every CSS import into valid ECMAScript module where all styles will be assigned to a constant with the name vitejs. And then this code will also include these styles as separate style elements inside of head element, as we can see right here. And as a result, on the page we see text with orange color. And now we're gonna go back to the editor and do the following. Let's include suffix module in every of these imports. And this is gonna be kind of a hint for Vite to treat this CSS import in a special way. So what Vite is going to do whenever it sees such import with word module, it is going to apply transformation to convert this CSS module into valid ECMAScript module. And this module, as a default export, will have a JavaScript object with styles. And of course, we can import such objects from CSS modules and assign it to appropriate variables, for example, to style A variable and style B. And just to see exactly what we're gonna get in these variables, let's print each of those variables in a console. And in order for this to work, we should also rename appropriate CSS files and use module word in names. So let's do this. Rename first module for A by adding module word, and also do the same with second module for B. And if we take a look what we get in a browser when we were requesting every CSS module, we see that the Vite has applied conversion to turn CSS modules into ECMAScript module. But this time it has also converted our original class names into unique strings, as we can see. And also, since we printed exported objects in the console, let's just see how these objects look. So, as a key in here, we see our original class name that we have used in CSS module files. And as a value, it has corresponding converted class name, which is unique per CSS module. So on the page, we're gonna see two style elements that include both of these unique class names. And every style element corresponds to one CSS module. So now we don't have to worry if we're gonna have two equal class names in more than one CSS module, because generated classes will be unique. And let's see it in action. So I'm going to query element with class heading and assign to property class name class of the first CSS module. So I'm referring to the first CSS module object styles A and use class name which is stored within heading property. As we can see, this key corresponds to our original class name, but the actual value which is stored under this key is unique class name. So by applying only this heading class from the first module, we're gonna get only one property applied, font size, and another property which makes text color orange, which belongs to another CSS module, was not actually applied, because every class name is unique per CSS module. And if I would like to also apply text color, I'm gonna have to manually assign CSS class from the second module styles B in the same way by referencing heading property. So right now we see that both those CSS rules have been applied, because we have manually assigned unique CSS classes to this h1 element. And as for transformations that Vite makes with our CSS modules, we can see that our original CSS module code gets converted into the following code, where class name becomes unique, with unique hash appended to class name. And after Vite has applied this transformation, it is going to transform this CSS code into valid ECMAScript module. So after running this code in the browser, the styles will be added to the page. And this module also exports object, where key is our original class name and value converted unique class name. And this is how we were able to import CSS module within JavaScript file. So we have received default export into this styles A variable, which contains our original class names as keys and converted unique class names as values. And since here we use syntax of native imports of ES modules, we can just as easily use the structuring and fetch only those parts that we need. For example, we want to fetch only class that corresponds to heading. Let's use here variable heading, assign an alias, heading font size, just to avoid collision with another CSS class that we are importing in here. We can also assign unique alias, heading color. And then we need to reference these new aliases when we assign these classes to heading element. And sure enough, we're gonna end up with the same result. And this is how we can work with CSS module specification in Vite projects. We have already seen how to import CSS files in JavaScript modules, and also in the previous lesson we have taken a look how Vite works with CSS module specification. And in this lesson we're going to see how Vite allows us to apply PostCSS transformations to CSS imports. And just to demonstrate how to work with PostCSS plugins in Vite projects, we're gonna install very popular PostCSS plugin, which is TailwindCSS framework. So in docs, let's open up installation instructions. In this case, we're installing TailwindCSS in Vite project. So let's use page how to install TailwindCSS within Vite project. And here we can skip the first step, because first step initializes default Vite project. But we already have a project, so let's go directly to step number 2 and install all necessary packages to provide support for TailwindCSS. The first command is going to install the following packages: TailwindCSS, PostCSS and autoprefixer. And the second command is going to generate two configuration files. One for TailwindCSS called tailwind.config.js, and another file is PostCSS configuration. And by the way, generated PostCSS configuration file already contains necessary plugins which provide support for TailwindCSS. That is TailwindCSS plugin itself and autoprefixer to provide support for modern CSS rules in most browsers. And now we need to tell TailwindCSS utility which files will include TailwindCSS classes, and we can do it by specifying value for content property. Here we just list paths to all the files with TailwindCSS classes, and since in our case we're only going to use Tailwind classes within index.html, let's just mention paths to this file. And on the next step, we're gonna have to add the following TailwindCSS directive to our main CSS file. So let's copy over these three directives. So inside of our project, let's create new CSS file, 5.css, inside of assets folder, and place those three directives in here. And finally, after we restart server by running npm run dev, we can start using all available Tailwind CSS classes in our source files, like this. So first of all, let's restart our server by pressing Ctrl+C in here to stop the server, and run it again by running npm run dev. Let's clear out everything within main.js file and leave only import, which includes Tailwind CSS. So we only import 5.css file because this is the file where we previously included Tailwind CSS directives. And now when browser encounters this CSS import, it is going to make request to our Vite server, and Vite server is going to respond with valid ECMAScript module, which means it has converted our CSS file with included Tailwind CSS on the fly. And whole Tailwind CSS style sheet has been assigned to Vite CSS constant. And then this constant has been used to inject these styles onto our page. As we can see, this style includes generated Tailwind CSS style sheet. So let's go ahead and try to apply a couple of Tailwind CSS classes to our heading. Let's copy over code of this background color from this file and style our h1 heading. And in Tailwind CSS, the class which corresponds to background color starts with bg. And then here in square brackets, we can specify dynamic value of the color. So let's paste that hexadecimal code. And let's also make text color white. And let's better apply those classes to the body element. And here we go. In DevTools, we can see that the appropriate Tailwind CSS classes have been generated. And sure enough, proper styles have been applied. And in terms of transformations, let's see what transformations have been applied to our initial CSS file. As we know, our initial style sheet contains only Tailwind CSS directives. So Tailwind CSS plugin that we have included in PostCSS configuration has turned these three directives into full Tailwind CSS style sheet. And then Vite has taken this generated style sheet and applied another transformation, which eventually turned this style sheet into valid ECMAScript module. So at the end, this code was run in a browser, and Tailwind CSS styles have been included on the page. Let's just try to use another Tailwind CSS class to make font size 30 pixels. And in a browser, in order to see newly generated class, we don't even need to refresh the page. All modifications are reflected on the page instantly, thanks to Vite hot module replacement feature. And this is how we can work with PostCSS transformations in Vite projects. We just need to create PostCSS file in our project, install all necessary PostCSS plugins, then include those plugins in PostCSS configuration file, and Vite is going to automatically apply all necessary PostCSS transformations to all imported CSS files. Let's see how easy it is to use CSS preprocessors in Vite projects. And for demonstration purposes, we're going to use Sass. So let's open up our main JavaScript file and import new style sheet with the name 6.css. Let's go ahead and create this file in assets folder. By the way, this will be a Sass file. So in main.js, let's change this extension on Sass. And now we're basically going to use arbitrary CSS rule, convert this rule invalid Sass syntax. And then let's also switch over to index.html and remove all TailwindCSS classes that were left since previous lesson. Vite provides support for different CSS preprocessors such as Sass, Less, Stylus out of the box. So all we have to do is to install CSS preprocessor we'd like to use. In our case we're using Sass, so let's run this command and install CSS compiler. After that, we need to restart our development server, so let's run npm run dev once again. And in a browser we'll see that those styles that have been specified within Sass file have been applied. That means Sass successfully compiled our source file, and it was successfully served to a browser. And as a response, Vite has returned compiled CSS file in the form of string, which has been assigned to this vitejs constant. And of course, this ECMAScript module has run, and our styles have been injected on the page, as always within head element. And if we'll take a closer look at the transformations that Vite has applied, we'll see that our source Sass file has been firstly converted to valid CSS syntax, and then Vite has transformed this code once again to convert it to valid ECMAScript code, which will inject CSS code on the page. And by the way, along with CSS preprocessors, we can also use CSS modules at the same time. And for this, we need to use module word. In file name, let's rename this source file. We have already seen how to work with CSS modules in one of the previous lessons, so we're not going to spend too much time on this here. Let's just see what is going to happen when we import CSS module like this, which also has preprocessors code. And let's take a look what value we're going to get in this styles variable by printing it in a console. If we leave it as is, in a console we're gonna get an empty object. So let's go back to Sass file and change this selector on class, for example wrapper. And there we go. Now this object contains one key which corresponds to class name, and the value will be generated class name with random hash. And of course, CSS rule that corresponds to this unique class name has been injected within head element. And now in our JavaScript file we can use this class name in whatever way we'd like. For example, let's manually assign this class to the body element, like so. And of course, in a browser we will see that this rule has been applied to our heading element. And this is how easy it is to work with CSS preprocessors in Vite projects. Vite allows us to work with JSON files very easily. All we have to do to use some JSON file in our JavaScript file, we just have to import it as usual, as native ECMAScript module. And let's see it in action. So in here I'm gonna import some JSON file and accept default export from this module in data variable. And then let's create basic JSON file with a couple of fields, for example, name and age. This object will describe a person. And then just to see what we're gonna get inside of data variable, let's print it out in the console and check it in the browser. And first of all, what is going to happen in a browser whenever it encounters our JSON import right here? It is going to fire a call to our server to fetch this JavaScript module. But since this file is not a valid JavaScript module, Vite has to process this import first and convert JSON file into valid ECMAScript module. And eventually, by doing a call to fetch this file in a browser, we're going to get the following in the response. So every field of that JSON object was exported here separately, and additionally, the whole JSON object gets exported as default export right here. And by printing that value which gets exported from JSON module, we will get plain old JavaScript object in a console with properties name and age. And as for transformations which Vite is going to apply to our JSON module, we can see that it converts JSON syntax into ECMAScript syntax, which of course allows us to import JSON files as normal ECMAScript modules in our JavaScript source files. And since the default export that we get is normal JavaScript object, we can easily apply the structuring and extract only necessary fields, name and age. And sure enough, in a console we're gonna get value of every field exported separately. So this is how easy it is to work with JSON files in Vite projects. In this lesson we're going to take a look at how to import static assets. So let's just create new directory in our project we're gonna use the following paths: source, assets, img, and in here we're going to move our image javascript.svg. And now let's try to import this image in our main JavaScript file. So I'm going to add import statement, and let's just reference that file that was previously moved within img folder with the name javascript.svg. And just to see how Vite is going to handle such image import, we're going to print value of this image URL variable in a console. And as we can see, Vite has given us full path to that image. So when our browser requested our main JavaScript file, we see that the import of our image was transformed a little bit by adding import query parameter to the end of this path. And once browser has made another request to fetch this file, we can see that Vite has given us valid ECMAScript module with the default export, which points to that image in our project. So basically this ECMAScript module returns path to their exported image. And of course that path was assigned to image URL variable, which we have printed in a console. And now we can do with this path whatever we like. For example, let's add a new element image into our HTML file with an ID of image. And then from the JavaScript code, we're going to get an image by using getElementById method. And then we can assign that path to source attribute. So the image will be displayed in the browser. And as we can see, it worked. And in a browser DevTools, source attribute contains path of the exported image. And of course that image is shown on the page. So once again, when we have imported our image in the main JavaScript file, the path to this image was saved into image URL variable. And then we used this variable to assign to source attribute of image element. And this way image was displayed on the page. And besides importing images like this, we can also import other file types, for example JSON file. Let's try an example. Here I'm going to import JSON file from the assets folder, and within this path I'm also going to include URL query param, like so. And now let's see what this param URL is used for. We're gonna print this URL in a console, switch over to the browser, and right here when our browser has requested JSON file by the following address, instead of exporting JSON object as we have seen in one of the previous lessons, by adding URL query param to this path, Vite has transformed exported JSON file into valid ECMAScript module with the default export, which actually points to imported file. But what if while importing images, we can receive content of an image instead of the path to this image? So in such cases, we can use another query param called row, like so. And in this case, instead of giving us URL to this image within image URL variable, Vite will return the content of the file javascript.svg. And we can see this content was printed in a console. So in terms of transformations, if we take a look at javascript.svg request here, we see that the Vite has transformed the requested file path into valid ECMAScript module, where default export is the whole content of this image. So in this lesson we have taken a look how to import static assets such as images into JavaScript files. And additionally we have also taken a look at a few query parameters we can use while importing static assets such as URL and row. In the root of Vite project there is a special folder called public, and this is the folder where we can store all our static assets. But of course, as we have already seen, static assets can be stored in different directories such as source. So what's special about this public folder then? And the thing is that all static files stored within public folder, they cannot be referenced in our source files. For example, we cannot import them like this, as we are importing javascript.svg file in here. So that means that Vite does not process all those files that are stored within public folder. Let's see an example. I'm going to add one more image tag in here and reference image from public folder with the name vite.svg. So at this point our page shows two different images. One image was imported directly in our source file, and browser has requested the module which exports path to the first image, javascript.svg. This is the image which was referenced from within our source file. So we manually imported this image as a ECMAScript module. But if I take a look at another image and the way how this image was fetched, we will see that in this case browser has requested this image directly by its name as a normal static file. And so whenever we want some static assets to be accessible as normal static files, so we can reference them by name, we have to place such files within special public folder in Vite project. And by the way, all the files that we will store within special public folder, they cannot be referenced from within source code, meaning that we cannot import them directly as ECMAScript modules from within JavaScript code. And all files that are located within public folder, they will not be processed by Vite during the build. So for example, if I'm going to try to build this project right now by running npm run build in the terminal, among the build assets in here, I'm going to see that JavaScript image, which we referenced in the source code. So Vite, while importing this image, has made some transformations to it and appended random hash to its name. But in this output, we don't actually see another image with the name vite.svg, which we have placed into public folder and referenced in HTML file. And that means Vite hasn't done any transformations to vite.svg image. So what it did instead is it took this image from the public folder and copied it into dist folder. And this dist folder was generated by running npm run build command. So this is the folder where Vite places all build files of our project. For example, we want public folder to be renamed on build folder. For such cases, Vite provides us with another option that we can add into the vite config.svg called public dir. And in here we specify desired folder name for static assets. I'm going to specify build. Of course, after this, I also have to rename public folder on build. And let's try to run the build again by running npm run build in the terminal. As we can see, this time build was also finished successfully, and that static file vite.svg was successfully copied from the build folder into our dist folder with the build project. So that means that Vite has recognized new name for our static folder build, and we are still able to reference our static file vite.svg from the source code. So let's remove that option public dir as well as folder with a build project dist, and let's rename folder with static files back to public. And just to make sure that we haven't broken anything, let's run the build command again and see if project will be built successfully. As we can see, nothing was broken and build still works. And besides these commands npm run dev to run development server and npm run build to build a project for production, initially Vite also defines another command called preview, which is going to run simple static server. And this server is mainly used to serve folder with build project files. And this way we can check how our project is going to behave by using production build files in the production-like environment. So now that we have already built the project and generated dist folder, we can run this npm run preview command to run static server inside of that dist folder. Let's do so by running npm run preview. As we can see, this static server was run on port 4173, and by opening up this address in the browser, we don't see any visual changes. Our project still looks like in the development mode. But in fact, if we will take a look at the request which fetches main JavaScript file, we are not going to see any ECMAScript import statements in here, because during the production build, Vite has actually taken all the modules and bundled them within one JavaScript file, and this resulting JavaScript file was fetched in one go in the browser. And this is how we can run simple static server to serve all the files from the build folder. Now let's go back, stop this static server, and instead run development server by running npm run dev. And since we don't need the folder with the build project anymore, let's remove it and finish this lesson. Vite supports importing several modules from the file system by using a special function, which we will review in this lesson. So first of all, let's clear main JavaScript file. Let's also go to index.html and remove img element with an ID of image. And now back to our main JavaScript file, and in here we're gonna write the following. Let's create constant with the name modules, and a special function which Vite provides us with is called Glob, which we will call on the meta object. And here we're going to specify paths to those modules that should be imported. And by the way, in here we can also use so-called Glob syntax, which is kind of like simplified version of regular expressions. So for example, I'll say that I wanna import all JavaScript files within a folder with the name 10, and I can do so by specifying asterisk instead of file name. And of course, to import these modules, first of all we have to create them in our project structure. So let's create folder with the name 10 within source folder, and in here let's create 3 modules. First one is a.js, and just to see that our modules will be imported, we're going to place here simple console log statement. And the same thing we're gonna do with the rest of modules. Second module will be b.js, which is also going to contain simple console log statement. And finally, third module will be called c.js. And in here, let's see what we get into this module's constant by printing it in a console like this. And as we can see in a console, we get an object where every key of this object corresponds to a path to a particular module. And the value of each key is a special function which we can use to dynamically load particular module. And actually, before proceeding any further, let's take a look at the transform main.js file which browser has received. So once Vite has discovered that call to a Glob function, it has transformed this call into such form where we can see the usage of the method assign, which creates an object where every key of an object points to individual module we're trying to import, and as a value for every key, it has a function which contains instruction to dynamically import particular module. And now we can simply iterate over keys of this object. Let's do this by using values method on the object. And here we need to pass the object which values we have to iterate over. So we're using our modules constant, then let's call method for each to iterate over values of the module's object. And on every iteration we're gonna get a function which we can use to dynamically load particular module. And this function returns a promise, so we can chain then call, and when the promise will be resolved, once our module will be imported. As a parameter in here we're gonna get the result of execution of the imported module, and which is why in the console we have 3 different log statements. And each of these statements comes from modules imported dynamically. So on the initial page load, browser has instantly requested these 3 modules. As we can see, we have requests for every such module in the network tab, and therefore this console log statement was also run, which produced those log statements in a console. And now let's print out the value of the data variable, which we receive after promise gets resolved, after dynamic module import. So for now we're not going to see anything interesting within these objects, they're basically empty. But what we're actually supposed to get within these objects is the actual data which gets exported from the dynamically imported modules. And as of now, our dynamically imported modules do not export any data, which is why those objects are empty. So now let's go ahead and try to export something from module A. We're going to use default export and export number 2. From the next module b.js, we're going to export constant name with value John. And right now, within those objects, which we receive after promise gets resolved, first object is going to contain the key default, since we use default export within the first module, and it contains value which we export, that number 2. And the second object contains property name, because this is the constant name which we export from the second module, with the value John. But even though those imports of modules A, B, and C are considered to be dynamic, they are executed right away when we load the page. And now let's try to change our code in such a way that these modules will be loaded only after some event occurs. For example, on the document object, we can register a listener for a click event. And within this event handler, we can place all this code which is going to dynamically import our modules. And now on the initial page load, we're not going to get any data within the console. As we can see, no logs are present here. But after I click on the document, In the network tab, we can see that 3 new calls are being made to fetch our modules A, B, and C. And of course, after execution these modules, we receive logs in a console, as well as the data that gets exported from those modules. And now a couple of words about the configurations, which we can pass when calling Glob method. So as a second parameter in here, it receives configuration object, and one configuration option is called eager. This option literally disables dynamic nature. And even though based on our current implementation, dynamic modules are supposed to be loaded only after clicking on the document, with this eager option set to true, our modules will be loaded instantly on the initial page load. Let's check it out. And right away on the initial page load, as we can see, our console contains 3 log statements, which is a hint that our dynamic modules were loaded and executed. And appropriate network requests to load dynamic modules we can see in the network tab. It's these 3 modules A, B, and C. But also let's see what is going to happen this time when I will click on the document. And in the console we're gonna get an error saying that module is not a function. And this is because we have used eager configuration option with value true, and the returned modules object no longer contains functions that we can execute to load dynamic modules. And let's see what it contains instead by printing the value in the console. So as we can see in here, we got an object where every key is passed to a particular module, and instead of the value being a function which we can execute to load module dynamically, this time all modules were loaded immediately on the initial page load, and as values in this object, we have exported data from those modules. For example, first object contains key default, because first module uses default export, and the second module contains key name, because we export constant with this name from that module, and the value John. And as for the transformations which Vite has applied to the call to Glob function, we can see that it converted that call into such 3 import statements, where each import statement imports particular module, and the data which gets exported from every module is being saved as a value for keys of the resulting object that we store within modules constant. And of course, the same transformation which is being made on our JavaScript source file, we can see if we take a look at our plugin inspector in here. And this is how we can use special Vite function called Glob to import several modules at once. But this is definitely not all what Glob function can do, and in the next lesson we're gonna review some additional details about this function. Let's continue reviewing function called Glob to import several modules at once. So in the previous lesson we have reviewed one configuration option with the name eager, and in this lesson we'll continue reviewing some other options. For example, we can also use option called as, and in case we specify value row for this option, then the object which Glob function will return is going to contain the following. Every key of this object will still be passed to a particular module, but the value is different because this time it contains content of those modules, instead of the function which allows us to load particular module dynamically. So when browser were requesting those modules to fetch them, as we can see, Vite has replied with the following content. It has produced valid ECMAScript module where default export contains module content in a string form. So literally what Vite has done, it read content of every module, converted it to a string, and returned to a browser. But if I'm going to specify value URL for the option as in here, this time Glob function is going to produce the following result. We still get an object where every key is passed to individual module, and the value this time is absolute path to those modules. So as a response to calls which fetch those modules in the browser, Vite has returned the valid ECMAScript module where default export is passed to that module. And now let's try to do the following. I'm going to add an export of constant name into every module. In the first module, this constant will be equal to Jane. The second module B already contains this constant with value John, so let's add the same constant into module C. And the value in here, let's say, will be Johnny. And I'm also going to place default export into every module. The first module will export letter A as a default export. the second module will export letter B, and the third module will export letter C. And then back to our main JavaScript file, let's remove this configuration object that we're passing to Glob function, remove the comment from this chunk of code, and this time let's use one configuration option called import. And what this option allows us to do, it lets us specify named export, which we'd like to import while importing modules in bulk by using Glob function. So for example, if every module we're trying to import in bulk contains some named export, instead of importing anything else, we can literally specify a particular import that we'd like. And since all our modules export constant with a name, we can specify this name in here. And since we have already specified that every import should contain import called name, that promise, which will be resolved after dynamically importing module, will contain this data. So let's rename this parameter on name and use it to print it out. And there we go, after every dynamic module gets fetched and executed, we also see the value of the name variable in here, which contains names. And if, for example, I only want to import default export, we can literally mention default in here, and this time instead of names we're gonna get values exported by default from those modules. And let's take a look at one more combination of configuration options. We're going to use eager option with value true and the import option with value name. And by now we already know that by using these configuration options, we disable the dynamic nature of importing modules, as well as we specify that we'd like to import only imports called name. And as a result, we're gonna receive such object where every key is a path to individual imported module. And as a value for those keys, we receive values of the named exports called name. So all our three modules, A, B, and C, were requested and fetched on the initial page load. And now let's also take a look at the transformation what Vite has applied to Glob function call. So right here we can see it was transformed into 3 static imports, where every import imports only one piece of data called name. And down here, all this data gets gathered within one object, and this object gets assigned to modules constant, which at the end gets printed to the console. So as we can see, this Glob function, which Vite provides us with to load several modules at once, is pretty powerful and lets us import multiple modules in several different ways. In this lesson, we're going to check how to work with a JSX specification in Vite projects. And additionally, we're going to implement our own custom JSX specification. So let's get going. First of all, we're going to clear out our main.js, and in here, we'll add only one import. I will import the file with the name 12.jsx, and right away let's create this file within source folder. And as an example, we're going to add some arbitrary JSX code within this file. So let's create new constant template, and then let's use the JSX syntax and specify arbitrary JSX markup, kind of like we do in React projects when we create components. Here I'll create a div with a class wrapper, within which I'm going to put tag p, and finally this paragraph will contain anchor tag. And just to have some styles applied to our markup, we're also going to create CSS file with a name 12.css and import it right here. And as a content, let's just copy over all content from 3.css and put it within 12.css. And just because we're using CSS class called wrapper in our JSX markup, let's rename this selector on wrapper. And so that now we export constant with a name template from this module, let's go back to our main.js and apply the structuring to this import and extract only constant with a name template. And I'm also going to use console log statement in here just to see what we get within this variable. After that, we're going to get console error because currently our project cannot recognize JSX syntax. So we need to enable JSX support, and to convert JSX syntax into JS syntax, Vite uses another bundler called ESLint. And it also lets us specify a couple of options within Vite configuration file to kind of define our own JSX specification. And this way we're going to teach Vite how to process our JSX syntax. So let's go back to the file with JSX code. And here I'm going to create new local function with the name create. And later we will specify this function as a JSX factory function, which is going to be responsible for creating DOM elements based on our JSX elements. Let's do this right now. So let's open up Vite configuration file. And in this configuration object, we're going to specify options for ESLint within this internal object. And for now, the only option that we need is called JSX factory. And this is the option where we need to specify our function name, which will be responsible for processing JSX elements. So if earlier we have created the function with the name create, I'm going to use this name in here. And when Vite is going to process our JSX code, for every tag name it is going to call our custom function create. And it will pass 3 additional parameters. First one will be element, which will contain the tag name. The second one will be an object with attributes that we have specified on that tag within JSX syntax. And the third parameter will be content that we can put in between opening and closing tags. So before going any further, let's just see what we get in all these 3 parameters. I'm going to add another console log statement and print out every parameter. And this function will be called 3 times, 1 time per tag we have used within JSX syntax. So the first call to the create function has received 3 parameters with the following values. The element parameter equals to tag name A. The attributes that we have specified on the anchor tag consist of only one attribute called href. And finally the text that we have specified for this anchor element is link. The second call to the create function has received parameters with such values, when the first one corresponds to the tag name, and the other 2 for now do not contain any values. And the reason to that is because we haven't returned anything from our factory function yet. And as a content for a paragraph element, we use another element, which is anchor tag. And finally, these are the last set of 3 parameters that we get after calling create function 3rd time. Because the root element of our JSX markup is div, which has only one attribute class with the value wrapper. And because we haven't returned anything from our factory function yet, the 3rd parameter, which is supposed to be a content of this div element, holds value undefined for now. And now we're gonna get to fixing it. Going back to our create function, in here I'm going to create new constant called node. And based on the element name what we receive as the first parameter into this function, we're going to use native DOM API and create DOM node by using create element method on the document object like this. And now that we have our DOM element created, we need to take attributes object, which we receive as a second parameter, into this function, and iterate over all the attributes within this object. And to iterate keys and values of this object, we can use JavaScript method entries. And here we're passing object name, which we'd like to iterate over. And if this object will be null, we're going to fall back to an empty object. And this entries method is going to produce array with pairs, key and value, that are contained within attributes object. So we can easily iterate over this array. And as a first parameter, we're going to destructure these pairs. The name variable will hold the attribute name, and the value variable will hold its value. And finally in here, by using another native DOM API method called setAttribute, we can set attribute with a name stored in the variable name and assign it value stored in variable value like this. And down here we also need to check if third parameter also contains value, which is supposed to be a content for our DOM element. And if this value will be a string, we're going to create text node based on this string by using createTextNode method and pass received content into this method, and then reassign resulting text element to this content variable. And finally we need to append this text element into that DOM element we have previously created. So let's use append child method and pass variable content as a first parameter. And eventually we're going to return created DOM element from this function. So right now let's check one more time what values we're gonna get within every parameter that we print in here. The first call to the create function has produced the following result. As a first parameter we still get anchor element. The second parameter is object with attributes to this anchor, and the third parameter will be a content for this element. And then when Vite sees paragraph element within our JSX markup, it is going to call create function with this element as the first parameter. And since we have not specified any attributes on this P element, the second parameter is empty. And finally, just because this paragraph element contains another element A, as a third parameter we have received DOM element, which corresponds to an anchor. And this anchor element was created when calling that function create that we have implemented earlier. And finally, our JSX markup also contains another element called div. The create function gets called for this element. First parameter will be element name, which is div. The second parameter contains attributes of this element. We have specified only one attribute with the name class. And just because this element also wraps another element paragraph as a content within the third parameter, we receive this paragraph element. So now let's go back to the create function and remove this console log statement. And as we can see in our main.js file, we have another console log statement which prints out content of the template variable. And this template variable is supposed to hold DOM structure, which was created based on our initial JSX markup. So if we take a look in the browser, we will see that this template variable holds the root element of our JSX markup. For now it is represented as a DOM element, but to see the whole content as text, we can use another DOM property called outer.html. Let's use it in here and check console again. And now we see full string representation of our JSX markup. So this whole JSX markup that was specified in here, it was properly processed and turned into DOM structure. And then we have printed out its string representation in a console. And now what we're gonna do, instead of printing this markup in a console, we're actually going to create another div element in our index.html with an identifier of app. And then let's go ahead and add this whole markup in our page. So I'm going to use query selector to select element with an ID of app. Then let's call append child. And as a parameter we specify DOM element we wish to append within element with an ID of app. And as we can see in the browser, new element was appeared on our page, which is that whole converted JSX markup added within app element. But right now we can't really see the link well, so let's go ahead and change style. We're going to make the text color white for this link. And there we go, now we can clearly see the link. And what we're going to do next is to extract this factory function create and move it in the new module. We're going to create new file called 12-create within source folder and put that function in here. And of course we need to export this function from this module. But after doing this change, we're actually going to get error in the console saying that create is not defined. So right now whenever we're gonna use a JSX markup, we also have to import our factory function create from the new module 12create.js. Let's add a proper import statement in this file. And after this, as we can see, everything is working again. But yes, having to import this create function every time we wanna use JSX markup is not very convenient. So we can use another trick and specify option with the name JSX inject in the ESBuild configuration object. And here we can define what content should be automatically added to all JSX files. So we can add in here that import statement of create function, so we don't have to import it manually over and over again in JSX files. Let's just specify an absolute path to the module which holds our create function. And now even though we haven't explicitly imported create function in JSX file, we still can see that our JSX code was properly processed and resulting JSX structure was injected into the page. That is because Vite has automatically added proper import statement, which imports our factory function create at the top of the JSX file. And by the way, every usage of the JSX element in our JSX markup was created into such function calls of our factory function create, with proper parameters depending on the JSX element. So in this lesson we have learned how to write our own JSX specification and use it in Vite projects. Let's talk about TypeScript support in Vite. We're going to use a very basic example, just for demonstration purposes, how to integrate TypeScript into Vite project. So I'm going to create a new file with an extension ts. Let's call it main.ts. And in here we're going to declare a function sum, which basically is going to sum up two numbers. It will accept two arguments of type number a and b, and is supposed to calculate the sum of these numbers and eventually return number. So in here let's just sum up two arguments, a plus b, and down here we're gonna add console log statement to print out the result of calling this function sum with arguments 1, which is a number, and the second argument will be 2, but this time it will be a string. And before checking it out in the browser, we of course have to include this file to our page. And by the way, Vite allows us to include TypeScript files directly within HTML files, like so. So once it's done, let's switch over to the browser. And surprisingly, we don't see any errors in the console. And as a result, in the console we have number 12, which is the result of executing that sum function. So as we can see, after browser loads our file main.ts, it receives the content where all types have been stripped. So that means Vite has applied transformation to this file to remove everything related to TypeScript and leave only valid JavaScript code that can be run in a browser. So that means that Vite hasn't done any static type checks and instead only converted TypeScript syntax into JavaScript syntax. And which is why as a result of executing this function we got 12. Because instead of summing up two numbers, JavaScript has concatenated them. And there is actually a reason why Vite doesn't do any static type checking when converting TypeScript files into JavaScript files. And this reason is a speed, because to do full static type checking will actually drastically delay the whole build process. So what Vite recommends us to do instead, if we wanna run static type checking, is to separately install TypeScript compiler. We're going to do it right now, so in a terminal, let's run npm install TypeScript. And then we're going to use this compiler to separately analyze our TypeScript files and apply type checking. So in our package.json, we're gonna add one more script within script section with the name tsc. And what this script will do is basically run TypeScript compiler. But in our case, we don't need to transform any TypeScript files into JavaScript files. Instead, we want only run static type checking, since this will be done by Vite. And instead what we want to do is to actually run static type checking. So in here for TypeScript compiler, we're gonna use option called noEmit, which is not going to produce any JavaScript files and instead will only run static type checking. And now if we try to go ahead and run that script by running npm run tsc, we're gonna see the following error. And to fix it, we have to add TypeScript configuration file within the root of the project with the name tsconfig.js. And in here, the only option that we have to specify is to actually show TypeScript compiler where our source files are stored. So let's add a root-dir option with the value dot, which is kind of a pointer to the root directory of our project. So right now if we run the same command again, npm run tsc, this time we're gonna get a different error. And this is actually the error that we expect, that we have some type mismatches in our TypeScript file. So right now our TypeScript compiler works properly and gives us hints whenever we have type mismatches like this one. But actually running TypeScript compiler like this is not going to rerun it. Every time we're gonna make change to our source file. So to make TypeScript compiler watch our source file for changes, we're gonna run the same command npm run tsc, but this time we will also add flag watch. And from now on, anytime we're gonna make a change to our source files, For example, let's go ahead, switch over to main.ts and make a change by fixing this type error. And now that we don't have any type errors within this file, if we take a look at the TypeScript output, we can see that TypeScript compiler was rerun, and this time there are no errors and warnings being reported. So when it comes to running TypeScript in Vite projects, this is one of the Vite recommendations, to run TypeScript type checking in a separate process, to prevent deferring main Vite build process. But if we actually want to fully integrate TypeScript type checking process within Vite build process, there is a special plugin for it called Vite plugin checker. And this plugin allows us to fully integrate TypeScript type checking into Vite build process. And after that, all TypeScript related errors and warnings will be shown directly in the browser. And if we wish to use this plugin, the first thing we need to do, of course, is to install it by running the following command. So let's switch over to the terminal, paste here that installation command and wait until the installation process finished. And after installation is finished, next we have to configure this plugin by adding some instructions into our Vite configuration file. So first of all, let's add this import statement. I'm going to switch over to my vite.config.js and right below the inspect import statement, I'm going to paste new import statement for Vite plugin checker plugin. And one more thing to do to configure this plugin is to actually copy this function call and paste it into plugins section down below, like this. And this is actually all what's required to fully integrate TypeScript type checking within Vite build process. So right now, if we're gonna go ahead and get back that type checking error by converting this argument to string, this time during Vite build process, we're gonna see that the TypeScript error was appeared within the browser. So as we can see from now on, every TypeScript error will be shown directly in the browser. And of course, if we go ahead and fix this error and check the result in the browser, we no longer see any TypeScript errors. And now within such setup, we no longer need to run TypeScript compiler within a separate process. So let's stop the previous process that we have previously run in the console by pressing Ctrl+C, because TypeScript will notify us about any type-related errors directly in the browser. Now that we know how to integrate TypeScript within Vite project, in this lesson, we're going to see how to integrate ESLint, which is a static analysis tool for JavaScript. So let's get started, and in our main.ts file, we're gonna add one ESLint violation. Let's add a semicolon after this function declaration. And since we're gonna have to make ESLint analyze TypeScript files, there is a special plugin for it that we can use called TypeScript ESLint. This tool basically enables ESLint support for TypeScript. And as always, the first thing we have to do before using this plugin is to install all necessary dependencies. So let's copy over this command and run it in our terminal. On the next step, we will actually have to create configuration file for ESLint with the name .eslint.rc.cjs and paste there the following content. So in my editor, I'm going to create new file with this name, paste here all the content I have just copied, and then again let's go back to the browser, and as a third step we are ready to run our ESLint. So to execute ESLint we need to run npx ESLint, and as an argument to this command we specify the folder where ESLint should be executed. In our case it's fine to specify a root folder of our project, so I'm gonna use dot. Let's execute this command in a terminal, and as we can see, as a result there are a lot more errors as we have initially expected. And among all these errors, we also can see that error we have made intentionally by adding semicolon to the end of the function declaration. And by the way, the rest of errors are coming from analyzing JavaScript files. So we need to ignore all the JavaScript files and run ESLint only within TypeScript files. And to tell ESLint which files it should ignore, we can create special file for ESLint called .eslint_ignore. And here we can list those files that should be ignored. So, to ignore all JavaScript files, we can use the following notation, *.js. So after that, if we're gonna execute npx ESLint again, we're gonna see only one error, which is that error that is coming from our TypeScript file, where we have intentionally added semicolon to the end of function declaration. So as we can see, to run ESLint checks in Vite projects, we need to start a separate ESLint process alongside our main Vite build process. And this is also recommended by Vite to prevent deferring main build process. But if you don't want to do this and prefer that Vite will run ESLint during the build process, we can achieve it by installing the following plugin, Vite plugin checker. We have already used this plugin in the previous lesson when we were integrating TypeScript within Vite project. But besides of integrating TypeScript, this plugin is also capable of integrating other tools. And one of such tools is ESLint. And this time we're not going to install this plugin again, since we have already installed it in the previous lesson. So in here, let's open up documentation to run ESLint. And the first thing to do before running ESLint is actually install ESLint executable on a system. And then we're gonna make Vite use this executable to run ESLint checks. And to achieve it, we need to copy the following lines, go to our Vite configuration file viteconfig.js and paste those lines in here, like this. Here we're basically specifying the command which will be used to run ESLint. And as we can see, this command also contains paths to files that ESLint should scan. And since in our case TypeScript files is located within the root of our project, let's correct these paths by removing source folder. And after this, if we open up our browser again, we're gonna see ESLint error in here. So our ESLint integration works perfectly, and now every time Vite is going to build our project, at the same time is going to run ESLint analyzer and show all ESLint errors in the following form. And by the way, the same output we can see in the server logs, in the terminal tab where we executed npm run dev command. And now just to see if this error is going to disappear, we're going to switch over to main.ts and remove this semicolon from here. Going back to the browser again, and this time we don't see any ESLint errors. And of course, message saying that no errors were found appears in the logs right here. And this is how easy it is to integrate ESLint into Vite projects. Vite offers handy feature called path aliases. So let's see how it can be useful for us. I'm going to clear out our main JavaScript file, main.js. Then let's just go ahead and import this CSS file into our main.js file. And of course, to import that, I'm gonna have to write down the whole path which leads to this CSS file, like this. And then let's add one more import, and we're going to import this image. So here, I'm gonna have to write the whole path to this image, which is contained inside img folder. And then inside index.html, I'm gonna add another img tag to display that image. But for demonstration purposes, we're going to use JavaScript for it. So let's select an element by an ID of image and assign the URL of an image to the source attribute, like this. So before switching over to the browser, we also have to change the extension of our main JavaScript file from TS on JS. And now let's see how it looks in a browser. So first of all, the imported CSS file was inserted onto the page in this style tag, and as we can see, our JavaScript image is also displayed on the right side. But there is a chance that over time our project will become pretty large, with lots of different imports, and those imports sometimes can be pretty long. And just to avoid always mentioning the whole path whenever we need to import some module, Vite allows us to define so-called path aliases, by using which we can drastically shorten our import paths. So let's just apply path aliases for these two imports. As an alias, I'm going to use @sign. And soon we're gonna map this character to point to source assets folder. And to define our own path alias, we have to open up Vite configuration file. And in here, let's add another configuration key called resolve, which will be an object with one more property called alias. And in turn, this will also be an object. Here, we need to define a mapping between our path aliases and actual paths that these aliases will be pointing to. So in here, I'm going to define one aliases that I have used previously. It's this @sign. And as for the path which this alias should be pointing to, I'm going to use Node.js helper called resolve to resolve the path to the folder source assets. As a first argument to this method, I'm going to pass the current directory name where this configuration file is located, and we can get it by using dirName magic variable. And as a second argument, we should specify our folder where our path alias will be pointing to. And at the top, let's just quickly test this out. I'm going to import this path module and write console log statement, and then see what is actually be printed after calling that resolve method with those parameters. So in order to see this log, I'm gonna have to restart our dev server by running npm run dev, and right here we can see that path that was printed by that method resolve, and it's exactly the path that we need. So our path alias will point to assets folder, which is located inside of source folder. And now in the browser, I'm not supposed to see any changes, so as we can see, the styles have been properly applied, and the image is also displayed, so that means that our custom alias was properly configured. And while importing those modules, Vite has replaced that alias with the proper path that that alias points to. And in our case, it is the assets folder inside of source folder. So at the end, let's go back to our configuration file and get rid of this console log statement. And this is how we can leverage path aliases in order to avoid long paths while importing modules. In this lesson, let's talk about environment variables and how to work with them in Vite projects. So we'll start with removing everything from our main JavaScript file, and in here, all I'm gonna do is actually print only one value. So Vite exposes all environment variables to the client code under a special object, which is stored inside the import meta object. So if I'm going to print the value of this object in a console, then in the browser we will see that this object already contains some default environment variables. For example, mode environment variables contains mode in which we have run Vite, whether we have run development server by using npm run dev or production build by using npm run build. And now if we're gonna go ahead and build this project by using npm run build and then open up the build project in the browser by running npm run preview, then after opening this URL in the browser and taking a look at those environment variables, we will see that this time value of the environment variable mode was changed on production, as well as value of prod variable. Now it's true, because now we are viewing build project in the browser. And next, let's see how we can define our own environment variables, and to do so, we have to create the file called .env, and in here we can list all the variables that we need. As an example, I'm going to create a couple of environment variables, Vite API URL and Vite another var. And for demonstration purposes, let's just assign random values to each of these variables. My dev server is still running, so let's open up the browser and see the result. And this time, in that env object, we have two more variables. Those are the variables we have just declared inside the .env file. And what's really important while declaring those environment variables, in order for them to appear in this object, we have to start the name of every environment variable with a special prefix, which by default is Vite underscore. Because if we're gonna try to create another variable without using the prefix, for example secret, and then let's take a look if this variable is available in the console, we will find out that this variable secret is nowhere to be found. And this is intentional behavior, because every environment variable which we're going to declare in the environment file will be potentially included in the build project, and those variables might contain some sensitive information such as database password. And to prevent us from accidentally exposing those environment variables to the public build, Vite forces us to explicitly use prefix in environment variable names to manually choose which environment variables should be available in the client code. And by the way, the prefix can be easily overridden. So to override the default prefix, we can go to the configuration file vite.config.js, and the option that we need to override the prefix is called env prefix. And here we just specify desired prefix. And this time, by looking at the environment variables again, we will see that none of those variables we have previously defined is visible in here. And that makes sense, because since we have changed the prefix, we also have to change this prefix when declaring those environment variables. So I'm gonna quickly change this prefix on our new prefix. And now, as we can see, those custom environment variables are back. So this is how we can define custom environment variables to be used in our client code by creating an environment variable file with the name .env. But since Vite can run in multiple modes, we can declare many such environment files. For example, if I only want some variables to be available in the production mode, I can create the file .env.modename. In this case, it will be production. And since by default when we run the build command by executing npm run build, Vite runs in production mode, so that means these two variables will only be available when building the project for production. So let's run the npm run build and then npm run preview to open up the build in the browser, and this time we see that these environment variables contain those values that were earlier specified in the file .env.production. And if we switch over to the first tab, where my development project is still running, here I'm seeing that those two variables have different values, the values from .env file. And when we start development server by running npm run dev, Vite runs in development mode. But we are not limited to only those two modes, development and production. We can use as many modes as we wish. So for example, for some reason I want to build a project for a different mode, let's say for staging. And this build should have different values for some of the environment variables. So to do that, I will just create another environment file, .env, and then following the same convention, .environment name. In this case, it will be called .env.staging. In here, just to demonstrate, I'm going to modify values of these two environment variables. And now we will try to build the project by using this staging mode. So to specify the custom mode that Vite should use while building the project, we need to write this. Right after npm run build, we use 2 hyphens, then another 2 hyphens. Mode, this will be an option name by using which we specify custom mode, and then we just specify our custom mode name, staging. And this time, let's take a look at the values of those two variables. And now let's open up the build in the browser by using npm run preview and take a look at those two environment variables. So as we can see, these environment variables have taken their values from the file .env.staging, because we have just built the project with using our custom mode, staging. And now in our inspector, let's take a look at the transformation that Vite has applied to this line when we are printing all environment variables in the console. So basically it took this line and assigned an object with all environment variables to the property .env. And if we take a look in the browser, it will be more clear. So let's take a look at the content of the main JavaScript file. And right here we can see that an object with all environment variables was assigned to .env property, and this way those environment variables are accessible in our client code. And besides accessing those environment variables in the JavaScript files, we can also access these variables in HTML files. So for example, let's print out the value of this app API URL variable in the index.html. And in order to print environment variables in HTML file, we just use a simple notation between percentage signs. We specify variable name, and this way this variable will be printed on the page. So in this case, since I'm running the development server, then this environment variables value was taken from .env file. But if we're gonna go ahead and build the project for production by using npm run build, and then take a look at the page, here we see a different value, because this value has been taken from environment file which corresponds to production mode called .env.production. Because as a reminder, Vite executes the build in production mode. But keep in mind that in order to use these environment variables in the client code, we have to use the prefix in their names. The default prefix is Vite_, but in our case we have overridden this prefix on up underscore. And one more thing that is also worth mentioning regarding environment variables is that we can also specify these environment variables while executing Vite commands. For example, here I'm going to start development server, and at the same time I'm going to declare environment variable up API URL. And by declaring environment variables in this way, it will override all those environment variables with the same name that were declared in any .env file. So if I'll open up development server in the browser, we will see that the value of that environment variable will be exactly the one that we have specified in the terminal while executing npm run dev command, because that value has overridden any values specified in any .env files. And that is how we can work with environment variables in Vite projects. Besides generating bundles for single-page applications, Vite also allows us to generate multiple bundles for several pages, one bundle per page. And in this lesson we're going to talk about how to actually generate several bundles for individual pages. And to demonstrate this, let's just do a little preparation. So for example, in our main index.html file, I'm going to add a heading called index. And also I'm going to add here a link which is going to redirect us to a second page called login. And now I'm going to copy over all the content of this file and create our new page. So in the root of our project we're going to create a new folder called login, and in here I'm going to add another JavaScript file which will be a script for our new page. And I'm also going to add HTML file for the login page. So here I'm going to paste everything from the index.html and modify a few values to differentiate this page. Let's just change the title text here on login, as well as the h1 tag. And the link on this page will point to our main page, index. And of course, let's also properly include JavaScript file to this page by specifying the proper path to login.js script, which is contained inside the login folder. And then let's also edit the title on the index.html page. And now let's run our development server by running npm run dev and check the result in the browser. So here we can see our main page index.html, since we have referenced the root path. And if I'm going to click on this link, we're supposed to be redirected on the second page, which is login. And this is exactly what is happening. So currently our project contains two separate pages that are completely independent of each other. And between navigating these two pages, browser actually makes full page refreshes. So now let's see what is going to happen when we build this project for production. Let's switch over back to the terminal and run the command npm run build. And here, as we can see, Vite has generated only one page, index.html. But we also expected another page, login, to be generated as well. So let's check the result in the browser and then we figure out why it didn't generate login page. So here I opened the build application, and if I'm gonna try and go to login page, as we can see the page didn't change, even though the address in the URL bar was updated. And this makes sense because Vite has generated only one index.html page when building project for production. And when we are trying to navigate to the page which doesn't exist, we are redirected to the main page. And the reason why Vite didn't generate the login page is because we are missing some configurations to tell Vite that we actually have more than one page in our application. So to notify Vite about several pages in our application that it needs to generate pages for, we need to add some configurations inside Vite configuration file. So in here, let's add an object build, within which there will be another object rollup options, which will contain in turn another object called input. And finally, in this object, we're going to list all the available pages in our application. And currently we have only two pages, so let's specify these pages in here. We'll call these pages main and login. And now, as values for the keys, we have to specify the full path to HTML files of these pages. Let's use function resolve to generate absolute path to our template index.html, and the same function we're going to use to generate paths for the login page, But here, let's also specify a proper path. Since login page is contained inside of login folder, we have to mention this folder in the path, like so. And before building our project again, let's add an import statement for the resolve function from the standard Node.js module path. And now switch over to the terminal and run npm run build again, and let's see what pages have been generated in this case. And this time, as we can see, besides our main page, we also see that the login page was also generated. And if we take a look at the generated folder with our project dist, in here we can see an HTML file which corresponds to the login page. So now if we're gonna preview this project in a browser and try to navigate to the login page, in this case, indeed, we were navigated to the login page. But please also note that there is no JavaScript bundle fetched for these pages, even though we have those JavaScript files imported in these templates. And actually, when we run npm run build, the JavaScript bundles are not generated. One more time, just to make sure that we are including proper scripts on HTML pages, our main page as well as login page. So the reason why there were no bundles generated for these JavaScript files is because currently these two files are empty. And just to make build generate JavaScript bundles as well, let's just add arbitrary statement in here. For example, let's console log something in the main.js as well as in login.js. And now let's regenerate build project again. And this time in the list of all generated files, we also see a couple of JavaScript files. One JavaScript file for each HTML page. And now we can use all capabilities of Vite inside these JavaScript files to continue our development and generate proper JavaScript bundles for every HTML page. So let's try it out. For example, let's assume that we have to import some CSS file. Well, not actually CSS, but let's use Sass as an example. And I'm going to create this login.sass file and put here some arbitrary styles just to make sure that while importing this Sass file, these styles will be properly applied to the page. So I'm going to make background color of the body brown, the text color will be white, and link text will be white as well. And the same Sass file I'm also going to create for our main page. Let's call it main.sass, paste the same styles. But to differentiate these two pages, let's change background color on indigo. So now let's not forget and also include this main.sass file inside our main script, like so. And now before generating the build, we actually have to do one more thing. In order for Vite to compile our Sass files, we also have to install Sass preprocessor itself. So we are doing this by using npm. Let's install Sass compiler. And now if we're going to start our development server by using npm run dev and take a look at the browser, we're gonna see that those styles have been properly applied to the page, which means Sass was compiled successfully. And if we'll switch over to the main page, we can see that background color changes because we have two different style sheets for these pages, index and login. And now let's see how everything looks when we build the project for production by running npm run build. And then again, I'm gonna run npm run preview to open up build project in the browser. And here we also can see that styles were applied. By the way, there is only CSS file fetched, as we can see in the network tab, and there is no JavaScript bundle for this page. And again, just because our JavaScript file contains only Sass import, Vite didn't actually generate JavaScript bundle at all. So just to make sure that it's going to generate those two bundles, let's add arbitrary JavaScript code in each of these files. I'm gonna add basic console log statement here, as well as inside login.js. And once again, we're going to rebuild the project and run the preview server and switch over to the browser. And this time in the network tab, we can see that besides fetching CSS file, there is also a request for fetching JavaScript bundle as well. So everything is properly working, and this is how we can generate several JavaScript bundles for multiple pages in case we're building multi-page app. And the most important thing when it comes to generating several bundles for different pages is to actually specify proper config inside of Vite configuration file And particularly what we have to do here is to actually provide a mapping between all our pages and absolute path for template files of those pages. And then when building project for production, Vite is going to make sure to generate separate JavaScript bundles for every HTML page. Vite also has mode which allows us to create libraries. And in this lesson, let's see what tools Vite provides us with to create npm packages. So for that, we need to do a little preparation first. Let's create an empty folder 18 and then switch over to this folder in our terminal. In here, I'm going to create two Vite projects. First one will be our client application, which is going to import the custom package we're going to create. And the second project will be the library itself. So let's start with creating the first client application. Let's run npm create Vite latest to scaffold default Vite project. I'm gonna call this project simply app. We are not going to use any frameworks, so I'll go with an option vanilla.js, and also we will not use TypeScript. And now right next to the app folder, let's create another Vite project, which is going to contain the library. So let's run the same command npm create Vite latest. I'll call this project lib, and basically make the same choices. We'll use vanilla.js without using TypeScript. So now let's just open up folders with these projects in a separate terminal tabs, and then we can start working on our npm package. So let's open up main JavaScript file of our library. From here, we're going to remove everything and install all npm dependencies by running npm install. Next, just to make sure that our application can be open in a browser, let's run development server by running npm run dev. Switch over to the browser and make sure application is loaded. Everything looks good, so let's start creating JavaScript file which will contain functionality of our package. I'm gonna place this file inside the source folder, and the file will be called index.js. So the package we're about to create will contain only one utility function called plug, which is going to accept array of objects as the first parameter, and the name of the key, which will have to extract from every object from the array as the second parameter. And in here we're going to loop over every object in this collection and extract key passed as a second parameter field. And eventually this function is gonna give us an array which contains only values of the specified key. And just to test out this functionality, we're gonna create an array of objects. For example, let's create array of users, where every object will contain two keys, name of the user and age. I'm gonna add 3 objects in this array and then populate each field with random data. Let's do the same for the age property, and down here I'm going to print the result of our function plug. We'll call this function with our array of users, and the property we need to extract will be name. And now in a console we're supposed to receive an array which will consist only of the user names. And of course, to execute this script in a browser, let's reference it from index.html. And as expected, we can see an array of usernames. But of course, since this project is intended to be an npm package, we need to build this project as npm library, and we need to tell Vite that our project is actually the package that other users can install. So let's create configuration file viteconfig.js and export configuration object. So let's add an object build, within which there will be another object lib, and by specifying this lib object, we are informing Vite that our project is actually the package, and Vite has to build this project differently. So the first option in this object is entry, which will basically point to the JavaScript file of our package. Let's use function resolve to resolve the absolute path to JavaScript file index.js, and then let's assign name to our package. I'm gonna call it plug, And also let's specify another option, file name. And this option will tell Vite which file name it should assign to the final bundled script of our library. As always, let's go ahead and write down an import statement for the function resolve that should be imported from the standard Node.js module path. And then all that code that was used to test our function, we are going to comment out, because this is not client application, so we're not going to use our function plug in this project. But instead, it is intended to be used by other users by installing our package into their applications. And now it's finally time to build our package. So in the terminal, let's execute npm run build. And looks like I have specified wrong path to the index file. Let's quickly get back to vite.config.js and fix this path. The folder name should be source. So right now, after I'm gonna build this project by running npm run build, we can see that Vite has generated two assets. Those are build files of our package. And the reason why there are two files is because Vite has generated two versions of our package. The first version will be used when users will import our package by using ECMAScript modules, and the second version will be imported if users will use function require while importing our package. So now let's take a look at the content of these files. Firstly, let's open up log.js, which is inside of a dist folder. Here we can only see the code of our custom function, which was minified a little bit, and then this function was exported by using alias plug. And this file is what's gonna be imported when users are going to import our library by using native ECMAScript module syntax. And now let's open up another file, plug.umd.cjs. So as was said before, this version of the library is going to be imported when users are going to use function require to import our library. But this is not all, and in order to make our package so that it can be imported, we still have to do some tweaks inside package.json. So here I'm going to assign different name to our library. Let's call it plug. Then we're gonna have to specify a couple more keys in this object, and specifically those keys are main and module. And by using these keys, we're specifying paths to the build files. So when users are going to import our library by using require, the file that should be imported in this case, we're specifying under the key main. And in case of the native ECMAScript modules, we're gonna import file plug.js. And now I'm gonna have to specify another object, exports, with almost the same content. Since our library is exposing only one import, meaning that it has only one entry point, let's specify this entry point. And here we have to use a couple more keys, import and require, and these keys will also contain paths to the files that have to be imported in case we're using ECMAScript modules or function require to import our library. So now everything is ready to actually start using our library in our client application. Let's go to our client application and open up main JavaScript file. Let's clear this file, and then we have to somehow import our library into this application without actually publishing our package in the npm registry. We are actually also going to see an example where we will publish the package, but it will come in one of the next lessons. And for now, I'm going to make our library globally available in the operating system. And npm allows us to do that by executing the following command inside of that library that we have to make globally available. And this command is npm link. So I'm going to execute this command in the root of our library project. And then later I will be able to link to this library from our client application. But for now, let's switch over to the root of our client application and install all npm dependencies. So now I need to get the code of our library in the node modules folder of our client application. And since we have previously made our library globally available in the operating system, we can simply link to that library by running npm link and the library name in the root of our client application. And right away we can see that this command has created the link with the same name as our library, and this link points to the source code of our library. And finally, it is time to test the functionality of our package in this application. So I'm gonna start development server, and now it's finally time to test the functionality of our package from our client application. And to do that, let's just copy over that commented code we have previously put in the JavaScript file of our package, cut it from here, and move it inside main.js of our client application. But of course, here this function plug should be imported from our custom package. So let's write down an import statement for this function and import this function using our package name plug, the same name which is used inside node modules folder. And by actually importing our library in this way, it will actually go ahead and import the function from this file plug.js, because we have previously specified path to this file inside the package.json of our package source code. And now let's just add some random content inside the index.html of our client application. I'm going to show a heading here. And here we go, we got expected result in our console. So our function plug, which was imported from our custom package, has extracted usernames from the array of user objects. So at the end, let's just recall what we have done in order to implement this library. In our library project, we have created a file with the name index.js, where we have implemented our function plug. And then by specifying an object under the key lib inside Vite configuration, we have told Vite that this project should be built as an npm package instead of a client application. And here under the entry key, we have pointed to the file, which contains the source code of our library. And we've also used a couple more keys to assign name to this library, as well as the file name that should be used for bundled JavaScript file after the build. Then inside package.json file, we have added some extra configurations to specify which files should be imported in case our users are going to import our library by using standard ECMAScript modules or by using function require. And then just to be able to use this library inside a client application without actually publishing this library to the npm registry, we have made this library globally available by running npm link in the root of this project. And then inside the root of our client application, we ran npm link and the library name that we had to add to node modules folder. And this command has created a special link inside node modules folder of the client application with the same name as our package name plug. And this link points directly to the source code of our package, which eventually allowed us to import this library from our application's JavaScript code. And these are the basics of developing JavaScript packages by using Vite. In the upcoming lessons, we're going to learn about this whole process even more. So in the previous lesson, we have developed the package by using Vite library mode and then included that package in here in our client application. And that time we had only one entry point in our package. But what if we'd like to create such package that would expose more than one entry point? And what I mean by that is this, that we could basically import some functionality like this from the subpath. So in this lesson, let's figure out how this can be done. Firstly, let's recall what functionality our package exposes. So in the index.js file of our package, we have only one function, plug. And then to be able to import this function from the client applications, we had to modify package.json file. And in here, we had to specify a key called module, where we have basically provided the path to our main library file with that function. And then in our client application, it would basically let us import in functionality from our package by using its name, like so. So now we're going to create another file which will also export some functionality. So in our package, let's create new file called log.js, which is also inside the source folder. And here for demonstration, we're also going to create only one function called log, which is basically going to be a wrapper around console log method. We're not going to complicate things too much because our main job here is to configure Vite in such a way so it can support multiple entry points of our package. So next we're going to add configuration to Vite config.js file to generate two different bundles for every JavaScript file of our package. so that later we could import function log from the subpath in the client application like this. So before going back to our package project, let's just use this function login here to print out array of users. Later we're gonna need this to test our package. And now back to our package project. Let's go inside vite.config.js, and here we're going to tell Vite about all our entry points of our package. So basically, instead of specifying in here only one path, we will convert this to array, which will contain all references to all files that we're going to expose in our package. So I'm gonna add another entry in here and reference that new file called log.js. So this way we have told Vite about all our entry points, and now let's see what will be generated when we run npm run build. So basically when we'll try to build our package, and as we can see, Vite has generated 4 files. So 2 files for every entry point, because in order to provide support for importing our package as a CommonJS module by using function require, Vite generates separate bundles. And that is why we have 4 JavaScript files here instead of 2. But they all have the same name, so how can we customize the name? And thankfully, that option, file name inside configuration file, also can accept closure. And this closure takes 2 parameters. First one is format, that we are generating bundle for either ECMAScript 6 or CommonJS module. And the second parameter here is the source JavaScript file name, which is in our case, all JavaScript files are contained within source folder. So the name parameter will be either index or log. And here I'm gonna use a basic condition and check if Vite is currently generating bundle for ECMAScript module. We're going to use the following format for the file name. And if Vite is currently generating bundle for CommonJS module, besides using name as a file name, we're also going to use custom extension for this file specified inside format parameter. And this way we have customized names that Vite is going to produce while generating our bundles. Let's see what those names are. One more time, let's generate our bundles by executing npm run build. And this time we still see 4 files, but all of these files now have more appropriate names. And again, all these files have been generated inside the dist folder of our package project. So now back to file package.json, and in here, in order to provide the way for importing our submodule by client applications, we also need to add an entry for our second entry point inside this expert object. So let's add another object and use the key log. This will be a key what client applications will use when they are gonna import our submodule log, just like we have already used in the main.js of our client application in this import. And also, since we have modified the names which Vite produces while generating bundles, we also need to correct these names inside package.json. So firstly, let's replace plug word with index in all these file names. And then one by one, let's correct every path so it points to the correct file from the dist folder. Otherwise, importing things from our package is not going to work. And now it's time to check if we will be able to import functionality from the submodule of our package. So, instead of publishing our package to npm registry, we have used one trick by running command npm link inside the project of our package in order to make this package available globally in the operating system. And in addition to that, to add a link to this package into node modules folder of the client application, we had to execute npm link but with package name inside the root of our client application, and this way this command will add link to our package inside node modules folder. And finally, let's get back to testing and run development server inside our client application so that we could test if we would be able to import functionality from this submodule log and then use this imported function to print out list of users in here. And now switch over to the browser, and as we can see, we have 2 logs here. first of which is produced by our custom function log that comes from our package. So importing functionality from the second entry point of our package worked fine. And we could even remove this log statement and instead print out result of the function plug by using our custom log function. Everything is working fine, so in this lesson we have reviewed how to build our library in case it has more than one entry point. And as we can see, it makes this process very simple. Let's continue in the next lesson. Alright, so far we have created the library with multiple entry points. And then in our client application we have imported the functionality from those two entry points right here, from the main entry point plug and from submodule log. And just as a reminder, the way we have organized the code in our library is as follows. So in here we have a couple of JavaScript files inside source folder, where each of those files contains only one function. And then to tell Node.js which modules have to be imported, whenever client application will import functionality from our library by using either main entry point or sub entry point, which in our case is called log, we have provided a path in here for every build file which corresponds to every entry point of our library. Whether client-side application is going to use native ECMAScript modules to import functionality from our package or CommonJS modules. In both of these cases, imports from our library are going to work fine. But so far we have only tested importing functionality from our library by using native ECMAScript modules. And in this case, Node, while importing these modules, looks into key import of the package JSON file of our library in order to find the file which it should import. And of course, each of these paths specified in this package JSON file points to build files of our library that Vite has generated during the build process. And it placed all these build files inside dist folder by default. So now let's see if it is going to work if in our client application, instead of using native ES6 imports, we're going to use CommonJS syntax by using function require. So I'm going to convert both of these imports to use function require like this. And all this I'm doing inside of the main JavaScript file of our main client application, which imports functionality from the library. And now instead of checking the result in the browser, we're going to run this script main.js by using node. So in the terminal, I'm going to run node and define name. And as we can see, we got an error saying that require is not defined in ES module scope. And in order to fix this issue, we have to rename an extension of this script on CJS, so that Node.js will treat this module as CommonJS module. But we are going to do it a bit differently, and instead of renaming the current file, I'm going to make a copy of this file with an extension of CJS like so. And then let's just revert all the changes we have previously made to the main.js file and leave file with an extension CJS as is, which still uses syntax of CommonJS modules with require function calls. And now again, let's execute main.cjs script in the Node environment. And in this case, as we can see, everything worked fine, we got the result. And as a reminder, this script just extracts usernames from the array of user objects, and then it prints out the new array, which consists only of usernames. So that's what we are seeing in here. So as you can see, it is possible to use our library in both cases, whenever client application uses native ECMAScript import syntax or syntax of CommonJS modules by using function require to import functionality from the library. And this is possible because Vite, while building our library, has generated two versions of our library, the one which is intended to be used with native ECMAScript imports, and another one for importing functionality by using CommonJS syntax, in other words, by using function require. And of course, if I'm gonna go back to the source code of our library, and in here I'm going to remove versions of CJS builds, those are the files responsible for providing support to import our library as CommonJS modules. Then after removal both of these files from the dist folder, index.cjs and log.cjs, if we'll try to execute our main.cjs script from the client application, which still uses CommonJS syntax to import modules from our library. In this case, we're gonna get the following error. Well, obviously because we have just removed those files that were previously providing support to import functionality from our package by using CommonJS syntax. So as we can see, it's very good that while building our library, Vite generates two sets of the build files. The first set of files is intended to be imported as normal ECMAScript modules, and the second set of file provides support whenever users are going to import functionality from our library by using require function. So let's continue reviewing possibilities of building libraries with Vite in the next lesson. So by now we have already created npm package and use this package in the client application. Let's start development server by running npm run dev to start our application in the browser. And the result of using our custom package is shown in a console. It basically have extracted usernames from the initial array of the user objects. And all of that has been implemented in previous lessons. So let's just recall how that works. In the main script of our client application, we are importing functionality from our package, but not only from the main module of our package, also from the submodule log. And currently the project which contains our package has two JavaScript files, index.js and log.js, and each of these files exports one function. And these two functions we are actually importing in our client application from different submodules. But as we can see, currently our package is pretty simple. It doesn't even use any third-party libraries. So in this lesson we're going to review how to integrate third-party library in our custom package. So in this file index.js we're going to import third-party library called collect.js, which basically has lots of utilities to work with array of objects. And we're going to leverage this function inside of our plug function, but firstly, let's just rename this function on plug and log. And then we'll basically do the same, which is extract a key from each object of the collection. But this time we're gonna use plug method on our collection. And we'll basically do the same here, but by using method plug, which library collect.js provides us with, like so. And then besides returning this result, we're also going to log the result in this function. And right after, we return this result. So besides the main purpose of this function, we're also logging the result in the console right away. And then let's see what is going to happen if we'll try to build this library. So in the terminal, let's run npm run build. And we are receiving the following error that the collect.js library cannot be imported since this library does not exist in our package. So what we need to do is to actually install this library by running npm install collect.js. And now once I'm gonna start the build process once again, this time it worked. We still see 4 build files, but this time we can notice that the sizes of some files drastically increased. For example, the size of the main file index.js is now almost 60 kilobytes. And that is because when we were importing library collect.js in our script, Vite has actually taken the whole source code of third-party library and put it in the build, and which is why the resulting file of our library has much bigger size now. But before we'll solve this problem, let's just import our new function plug and log in the client application and see if it's gonna work. So now we don't need to additionally call the log function in order to print results in a console, because the new function plug and log is going to extract keys from every object of the array, as well as print the result in a console. And in the console, as we can see, we are seeing expected result, with the difference that our result is contained within items property of the wrapper object. That's how the library collect.js works. It returns us not only the resulting array, but an object, which wraps our collection. But this is not the most optimal solution of building our libraries, because anytime we're going to import third-party library, the file size of our library will be drastically increased. So let's see what we can do about it and what Vite has to offer in this regard. So moving on, let's open up configuration file vite.config.js, and in here we're gonna add another option which is called rollup options, which will be an object with the key external, and this is where we have to specify library names which we don't need to be bundled along with the code of our library. And since by now we're using only one third-party library called collect.js, I'm gonna include only one name in this array, like so. And then let's watch the size of the bundled file index.js. So currently the size of index.js file is around 60 kilobytes, but after I rerun the build process by executing npm run build, this time we see that the file size was drastically dropped. And if we're gonna take a look at the content of the build file index.js, we're seeing only our code in here and the import of the library collect.js, but the source code of this library is absent, and which is why we don't even need to install the library collect.js in our project. So let's remove this dependency by running npm uninstall and dependency name, and let's just rerun the build process of our package once again by executing npm run build. So now if we'll go to the browser and check the result in our client application again, we're supposed to get an error since our package relies on the third-party library collect.js, but that library was not included in the build version of our package. But surprisingly, as we can see, we didn't receive any errors, so it worked. And the reason it worked is that previously when we started development server, Vite has gone ahead and cached some dependencies in the folder .vite, which is inside of node modules. And this folder has cached version of the library collect.js. So let's just go back to the editor, open up node modules folder of our client application, and remove that folder with cached dependencies called .vite. So now let's restart development server in the client application, and we are receiving an error that dependency client.js cannot be imported since it is missing from our client application as well as from the build file of our library. And the first thing that comes to mind is actually install this library into our client application. So let's do just that. I'm gonna execute npm install and specify library name collect.js. And then after running npm run dev again, we're receiving a different error, similar, but this time it could not resolve imports of our own package plug, because the link to our package, which we have previously added to the node modules folder of the client application by executing npm link, is gone for some reason. So let's just add the link to our package inside node modules folder one more time by running npm link and our package name. I am not going to explain in detail what this command is doing, since we were talking about it in one of the previous lessons. So now that we have added back link plug which points to our package inside node modules folder, we can try to start development server once again. And again, the previous error is back, that it cannot resolve dependency collect.js. So we're going to solve this problem in the next lesson, when we will publish our package to the npm registry. And then instead of using npm link to make our package available to the client application, we're going to install our package as any other third-party dependency by running npm install. It's finally time to actually go ahead and publish our package into npm registry. And as a reminder, we are already importing functionality from our package in the main.js file of our client application. And the way we made it possible is by linking our local folder with the package to node modules folder of our client application by running the following command npm link and the name of the package we'd like to link to our client application. And then as we can see inside node modules folder we have the new link called plug, which points directly to the folder with our library. And now instead of linking our local library, we're actually gonna go ahead and publish our package to npm registry. So first of all, what we have to do is to login. Let's run npm login in the root of our library, and we will be presented with a couple of prompts. Here we need to type in the username as well as the password that we have used to register on the npm website. And yeah, side note, we need to be registered upfront in order to log into npm. Then we also have to enter our email address, and right after we will receive the code on our email. So let's enter this code in here, and as soon as we're gonna see this message, that means we were successfully authenticated. So I'll switch over to my browser, and right here as we can see, I don't have any libraries in my npm account yet. So let's start the process of publishing our library to npm. First of all, let's go and open up file package JSON of our library, and here the first thing that I'm gonna do is rename the value stored under the key name. Besides the name of our library, I'm also going to use namespace. This namespace should match username of the logged in user. And what this will do is it will basically make sure that we are not gonna get any naming collisions, because there is a high chance that the package with the name plugged already exists on npm. And now in the terminal, to publish the package, we have to run npm publish. This time we get an error saying that our library is considered to be private. And the reason is that in the package.json file we have the key private with the value true. So let's remove this key, run npm publish again, and it looks like publishing private packages is actually paid feature. So when running npm publish, we have to specify one flag called access with access modifier. In this case, I'm gonna use public. So this way, our library will be publicly visible. And finally, the command has finished with no errors. And if I'll switch over to the browser, in here I can see that my library was published. Next, let's go back to the editor. Inside the client application, let's open up package.json, and here let's remove the only dependency collect.js. We're also going to remove the folder with this dependency from node modules folder, as well as special folder .vite that Vite generates to store cached dependencies. And now, in order to install the library I have just published, we can use npm install and the full library name. The full name is stored in here under the name key of the package.json of our library project. So let's see what is going to happen when we run npm install and our library name. As we can see, the library was successfully installed. And now I can run development server by running npm run dev. And here I see the following error saying that some of the dependencies were not resolved. And those dependencies are from our library. And the reason is that currently our client application inside main.js file references old paths to import functionality from our library. So we have to properly update this import paths by specifying full library name in here. Next, let's start development server again. This time we got a new error. And to understand what's going on in here, let's open up the folder with our package inside node modules folder of our client application, and here we can see that there is no folder dist with the build assets of our library. But in fact, inside the package.json file, we are referencing these files from the dist folder, because those are the files that have to be imported when users are going to import functionality from our library. So we actually have to do one more thing before publishing our package to npm. Let's go back to the package.json file of our library, and in here we have to specify the key files where we can list all the files and folders that have to be published. In our case, we only need to publish folder with the build assets, which is dist. So I'm going to specify one folder name in here. And then, once we do any change to our library, I'm also gonna have to republish this library, but with a different version number. We could update this version manually, or we could use npm command called npm version. So we also have to specify which version number we'd like to update, either the first one, second one, or the third one. In this case, it's not really important which one we're gonna update, so I'm gonna update the third one. And the word responsible for updating the third number is patch. Let's run this command. As we can see, our version number was updated, and also this number was updated inside package.json. And to grab the new version of this library in the client application, we have to reinstall it. And before installing the new version of this library in the client application, let's go inside node modules folder of our client application and manually remove the folder of our library from here. And right after that, we are ready to install a new version. Let's run npm install and our library name. And now if we'll take a look at the content of the library inside node modules folder, we can see here that this time only one folder is present, which is dist. This is that folder we have previously specified under the key files inside package.json of the library, and which is why only this folder has been published to npm. Let's run development server once again, and this time we also got an error, but the error message is different. So it cannot install the library collect.js, but in fact, we reference this library from the source code of our package right here inside index.js. But in fact, we have not installed this library in the client application as well as in our package. So this dependency is nowhere to be found. And the reason why this library was not included in the build file of our library is because inside vite.config.js, we have manually specified that Vite should not include this external dependency into final build of our library. So to fix this issue, we have to go inside of package.json of our library, and in here let's specify one more key called pure dependencies. And these are the dependencies that our library depends on, but it doesn't include those dependencies. So actually client applications will be the ones who will be responsible to install this library in order to use our package. So let's specify here one pure dependency collect.js. This way we are saying that our library depends on this third-party library. And then of course I'm gonna have to republish our new version of the package. Let's firstly update the version of our package by running the corresponding command. And then let's go back inside the folder with our client application. Let's remove our previous version of the library from node modules folder and reinstall it by running npm install. So what actually happened this time is this. Besides installing our library, we can see that inside node modules folder, there is collect.js folder, which means dependency collect.js was automatically installed along with our package. And the reason it was installed automatically is because we have previously specified this dependency under pure dependencies key inside of our library. So from now on, when any client application is going to install our library, the dependency collect.js will be automatically installed. And finally, if we're gonna run development server inside of our client application, eventually it worked, and in the browser we can see an expected result in a console. And also let's see if production build is also going to work. I'm gonna run npm run build to build this client application. The build has finished without errors, so that's good. And now let's run this build in the browser by running npm run preview. And then by opening up this URL, we see the same result as in development mode. So we were able to successfully publish our package to npm registry. And additionally, our package contains external dependency collect.js, which is not bundled with our library, so all client applications that are going to use our library, once they're gonna install our library, all third-party libraries which our library depends upon, which in this case is only one dependency collect.js, they are going to be automatically installed. So that's about it for this lesson. Let's continue learning Vite in the next one. In this lesson, let's review how we can optimize images by using Vite. And for that, I already prepared default Vite project. Let's open it up in the browser and start. So at the beginning, as always, let's just do a little preparation. Let's switch over to index.html file. And here I'm going to add an image. And in order for this image to not exceed the available width of the browser, let's assign width 100%. And then what we're gonna do inside main.js, firstly, let's clear everything from here and import an example image, which I'm going to add in this project in a bit. So then once we get the path to this image inside the image variable, let's just select DOM element of that image we have just added and assign the path of the image to the source attribute, like so. Let me just quickly add an image to this project. Here it is. This is how our image we're going to optimize looks like. And then in order to easily see the size of any file within VS Code, we can use the following extension. I already have this installed, and the way this extension works is it just shows the size of an active file in the status bar at the bottom right corner. I currently have my status bar hidden, so let me just enable it, and right here I can see the original size of this image. As we can see, this image is quite big, and the size exceeds 1 megabyte. And now before proceeding further, let's switch over to the browser and make sure that this image shows up. And everything looks good, we can continue. So in order to optimize images, Vite has several plugins, and one of them we're gonna use in this lesson. I'm going to use plugin called Vite Plugin Image Optimizer. So this plugin relies on two other libraries, Sharp.js and SVG.o, for image optimizations. So first things first, let's just install this plugin by running the following npm command. I'm gonna copy over this command and run it in my terminal. And then, since this plugin relies on two other libraries, those libraries have to be manually installed. So, one by one, I'm going to copy these commands to install these two libraries. Firstly, let's install Sharp, and right after that, let's also install another library, SVG.o. And once the installation process is finished, we have to configure this plugin, and the way we do this is by inserting this configuration into our Vite configuration file. Currently, I do not have this file, so let me create it and paste in here all that configuration. There is nothing special about this configuration, and the most important thing here is that we import and include our new image optimization plugin and add it to the Vite pipeline. Actually, this plugin allows us to configure a lot of things, but we're not going to review any possible configuration option, and instead, let's just see how to optimize an image with an extension .gpg. So let me copy over this configuration option and paste it into my vite.config.js. And by using this option quality, we can configure how much we want all GPG images to be optimized. So as an example, let's specify 80. And by the way, image optimization only happens when building the project for production. So I'm gonna have to run the build by using npm run build. And right here we can see the new output. This is the result of that image optimization plugin. And right away we can see in here that two images were optimized. The first image is that image we just added to the project, and another one, vite.svg, is the default one, which resides inside public folder by default. So as we can see, the size of the first image was reduced by around 300 kilobytes. And now to see the result in the browser, I'm gonna have to run npm run preview to open up build project in the browser. And by following the address localhost 4173, we can see in the browser build project. And there we go, we got here an optimized image, but the size here is a little bit different than the one we have just seen in the terminal. Anyway, our image optimization is worked. So now let's just change the value of the quality configuration option. For example, let's specify 40, and then rerun the build by running npm run build. And this time the image size was reduced even more. And of course, if I'll open up this build in the browser, we can see in here the newly optimized image with the size of 392 kilobytes. So let's review. In the editor, let's open up original image with the name image.jpg, and as we can see, the original size of this image was over 1 megabyte. But then when building the project for production, the size of this image was dropped to 344 kilobytes. And actually the point of this lesson was not to show you how the particular plugin works, but how to include any plugin into Vite, because the installation process as well as configuration will be pretty similar. And of course, there is not the only plugin which allows you to optimize images. There are also other choices. So we just have to pick that plugin which satisfies our needs, and then follow simple steps to install and configure this plugin, and then we'll be good to go. Let's keep exploring capabilities of Vite in the next lesson. In this lesson, let's explore how we can create our own Vite plugins. So I have already created default Vite project. Let's run development server. And just to make things a little bit easier while developing our plugin, let's use another plugin called Vite Plugin Inspect. And what this plugin will allow us to do is it will provide us with such inspector view where we can see all the transformations that are going to be applied to our modules by all plugins, including our own. So let's quickly install this plugin by using npm and run this command in the terminal. And then let's copy over this code to include this plugin. Let's create configuration file with config.js and paste in here that code. And now I'll have to restart my development server by running npm run dev. And in here, besides our app URL, we can also see inspector URL. And by opening up this URL in the browser, we can access our inspector. So if we see this page, that means our inspector was installed successfully. We can continue. So we're going to create our own plugin, which is going to allow us to import CSV modules and to transform CSV code into valid JavaScript arrays. We're going to use Node.js library called Node.csv. And since this library has several libraries in it, the one that we need is called CSV parse. So let's install this library by running the following npm command in our terminal. And then before actually getting to writing our plugin, let's do a little preparation by adding an empty pre-tag in our HTML file. And then let's switch over to main.js and remove everything from here. We're gonna start from scratch. So what we're going to do in here is try to import the CSV file we're going to create soon, and then all the content of the CSV file we're going to assign to that pre-tag, specifically to text content property, like so. But since products will be the array, firstly we have to stringify this array, and which is why we're calling method stringify to turn this array into a string. And of course, this statement should import CSV file, so let's change this extension on .csv. And then we'll add this products.csv file in the root of this project. And here I'm going to insert some random data. We're gonna work with products and their quantities. The first line will contain names of the columns of this CSV file, and all other lines will contain the data for every column, like so. And of course, by default, Vite does not support importing CSV modules, so when we switch over to the browser, we'll actually get an error. Because as soon as our browser tries to make a request to products.csv file, our server responds with the raw content of the CSV file, which is not the valid ECMAScript module, hence this import didn't work. So before actually importing CSV modules, we have to apply custom transformation which would transform CSV code into valid JavaScript array so it can be imported as other ECMAScript modules. So our transformed JavaScript array could be assigned to the products variable in here. And now we're gonna get to the main part of this lesson, which is creating the Vite plugin. So the Vite plugin is basically an object which we should add to plugins array in our Vite configuration file. So in here, let's create a new object. Firstly, we'll have to specify the name for our plugin. I'm gonna use Vite column CSV. And then most importantly, we have to provide a special function hook called transform, which in our case will be asynchronous. And this function will be called automatically by Vite whenever we're gonna import any modules inside JavaScript files. The first parameter of this hook will be the content of the imported module, and the second parameter will be the path to this module. I'm gonna call these parameters source and ID. So once we have fetched the content of the CSV module, we need to transform this CSV code into JavaScript array, which we can do by using function called parse. And this function is going to be imported from that CSV parse module that we have installed at the beginning of this lesson. Also to this function, I'm gonna pass configuration object with only one option, columns, that will tell this parse function that our CSV code contains name of columns as the first line in our CSV file, so it can properly transform our CSV code. And then let's go up and in here add an import for the parse function from the CSV-parse package and the sync submodule, like so. And then by following conventions of Vite, the transform function has to return an object which should have a key called code, and in here we have to provide valid ECMAScript code, which is supposed to be exported when people are going to import CSV modules in JavaScript files. And now very important thing to note is that this hook transform is going to be called anytime we're going to import any module inside JavaScript files, not only CSV files. So we actually have to restrict execution of this hook to only CSV modules. And we can do this by adding conditional and wrapping all the code by this conditional. So here we're gonna use a regular expression and check if the currently imported module is indeed CSV module, only then we're gonna run this transformation. Otherwise, our plugin is not gonna do anything when importing other modules. So just for clarity, let's also print some variable values in here, for example source, ID, as well as records. And then in the browser, we can see the result of our plugin. So there is no error anymore while importing .csv modules. And what we got instead is actually transformed CSV code into JavaScript array on the page. Let's just make this output a little bit prettier by adding style whitespace with the value of pre-wrap to place the content on multiple lines. And if we select the request, which was supposed to fetch CSV module from the server, in the response we can see that the response was turned into valid ECMAScript module, which exports an array of objects. And apparently it contains objects for every line from the CSV file. And then this variable was stringified and assigned to text content property of the pre-tag, which is why we're seeing this array in the stringified form on the page. And now in the server console, let's see the result of these variables. So if I refresh the page, these variables are supposed to be printed in the server console. And there we go. So this value corresponds to the variable source, which contains all content from the CSV file. And the other output, which is the path to the CSV file, corresponds to an ID variable. And finally, after executing this whole thing, we got the transformed CSV into constant called records, which was later transformed into valid ECMAScript module string. And this is actually the result of outputting that variable in the server console. So one more time, while importing .csv module in our JavaScript file, we got transformed CSV code into JavaScript array, and this JavaScript array was assigned to the products variable, which later was stringified and assigned to text content property of the pre-tag. And now let's take a look at the transformation of our custom plugin that was applied to CSV module. So let's open up an inspector, click on our module products.csv, and right here we see the following transformation, which corresponds to the name of our plugin, Vite::CSV. So our plugin has read the content of the CSV file and transformed this code into valid ECMAScript module. And that's about it. We have successfully implemented our custom Vite plugin, which allows us to import CSV modules in JavaScript files. Link to the source code will be in the video description. In the previous lesson, we have implemented the plugin which allows us to import CSV files inside of ECMAScript modules. And the way it works is as follows. Whenever we import CSV file, the CSV syntax gets transformed into JavaScript array of objects. But currently our plugin is kind of inlined inside of Vite configuration. But usually plugins are extracted into separate JavaScript modules in the form of factory function. So let's try to move it into a separate file. Just like it is done for the inspect plugin, here we're just importing this plugin and then calling it inside this plugin's array. So we're gonna do the same with our CSV plugin. Let's just cut this whole object, create a new file for this plugin in the root of our project. Let's call it Vite plugin CSV. And this module is going to export one function, which will be a factory function for our plugin. Here we're going to paste that whole object with plugin definition. Let's also move that import that we need in this plugin of the function parse. And since this function parse gets imported from the sync submodule, there is no need to make our transform hook asynchronous, so we can remove this async keyword from here. Let's also rename this plugin on simply CSV, and then let's get back to our Vite configuration and include this plugin by firstly importing factory function from Vite plugin CSV file. And then, just like it is done for inspect plugin, right next to it, we're gonna call our factory function CSV, and this way we have just included our own plugin. And please note that there is no difference between including plugins inline in the form of JavaScript objects or by moving them into factory functions and then calling those functions right here in this plugins array. So just to make sure that our plugin works as expected and we get the same result as before, let's run development server and take a look in the browser. As we can see, we get the same data. That means our plugin works as before. And now a couple of words about existing plugins that exist in Vite ecosystem. So first of all, there is a list of official plugins provided on the official documentation page right here. And then, since Vite internally uses another bundle called Rollup to build projects for production, there are a bunch of Rollup plugins that are compatible with Vite projects. And the list of Rollup plugins compatible with Vite projects can be found on this page. And of course, besides official Rollup and Vite plugins, there are countless of plugins built by the community. For example, there is Awesome Rollup repository, which has collection of resources specifically for Rollup. And this page also includes a list of community plugins. And similar page also exists for Vite. This repo is called Awesome Vite. Here we also can find a bunch of links to everything related to Vite projects, as well as plugins developed by the community. And now let's go back to our plugin configuration and consider a couple more options that we can use for our plugin. So an important option is called Apply, and this option allows us to specify which environment our plugin should be included into. For example, if we'd like to use this plugin only during development, we can specify value serve for this option, and this way, plugin will only be activated while we are running development server. And by using another keyword called build, allows us to include this plugin only in production builds. In other words, when we are running command npm run build to build the project for production. So let's see, for example, I'm going to specify value serve, which means the plugin should be included only in development mode. And then if I'll run production build by running npm run build, right away I get an error, because our plugin which lets us import CSV modules was not actually included in the production environment. And then if I'll go ahead and change this value on build, then while running development server, by executing npm run dev in the browser, we're gonna get the following error since our import of the CSV file didn't work. And besides specifying predefined values for this apply option, we can also specify a closure, which gives us more fine-grained control. This closure accepts a couple of parameters, first of which will be a configuration object, and another parameter will also be an object with a couple of useful properties such as command and mode. And then let's just print out each of those variables to see what they contain. And by looking in the console, we can see that the first parameter basically printed the whole configuration object, command variable stores value serve, and mode variable stores value development, since currently we are running Vite in the development mode. And based on these values, we can do an extra checks. And if we're going to return value true from this closure, that means the plugin should be included. So for example, if I'd like to include this plugin only during development, I'm going to compare variable mode with the development word, and this way, this plugin will be included only while running development server. And of course, if I'll go ahead and try to build a project for production, I'm gonna get the corresponding error saying that CSV module cannot be imported, since there is no plugin which recognizes such imports. Also, there may be situations where we need to access configuration object in other hooks, for example in this transform hook. So how do we get access to this configuration object from other hooks? And there is actually another hook that Vite provides as well, called config resolved. This hook will be called automatically before transform hook, and it receives configuration object, which we then can store in a variable, so it will be accessible to other hooks. So I'm going to declare here a variable called config before returning configuration for this plugin. And then inside config resolved hook, I'm going to assign resolved configuration object to this variable config. So then it's accessible from other hooks. And then based on configuration values, we can easily do extra checks in this transform hook. For example, let's compare value serve with the value stored in command variable. And based on that, we're going to specify this value as the value for option columns for the parse function. So now let's take a look at the difference. Firstly, let's run our development server and check the result, how our CSV code was transformed. As we can see, we got an array of objects where every key corresponds to the field from the CSV file, and every such object corresponds to individual line from the CSV file. And for example, if I'm gonna run development build, in this case we're supposed to get different result. So let's just run this production build in the browser by running preview server. And as we can see, the output is different. In this case, the first element of this array is another array, which consists only of column values from the CSV file, and all other elements store values from individual rows of the CSV file. And now let's review one more useful hook, which basically allows us to transform HTML content. And this hook is called transform index HTML, which is about to receive the whole content of the HTML file. So in here we can do all necessary transformations with the content of HTML file. So let's replace the closing body tag with the following. I'm going to put basic script at the end of the body element, which will open up a dialog with the word hello, like so. And it is very important to position all the hooks on the same level. So the transform hook as well as transform index HTML hook should be included on the same level like this. So now after running the development server in the browser, we can see that firstly we got an alert with the word hello. So our transformation of the HTML file was successful, and at the end of the body element we got that script, which opens up the dialog. So in this lesson we have only reviewed a couple of hooks that we can leverage in our plugins, but in fact there are a lot more of such hooks, and documentation about those can be found in the official Vite documentation. But even only using these hooks, we get a lot of flexibility, and we can transform imported modules in whatever way we like. Let's continue learning about Vite in the next lesson. Let's consider several options which allows us to configure development server. So when we start development server by running npm run dev, it starts with using port 5173, but then if we're gonna go ahead and run another copy of this server, the port will be changed dynamically, because the previous port 5173 was already taken by the previous copy of the development server. And of course this port is configurable, and just like other configurations, we can override the port in Vite configuration file. So let's create an empty Vite configuration file, and in here we're going to specify an object under the server key where we can configure several aspects of the Vite development server. So for example, I want the port to be 3333, and now after running npm run dev we can notice that the port we just specified was used for development server. But still, if we're going to launch another copy of the server, the port will be changed. And this is a pretty convenient behavior, but in case we'd like this command to throw an error if the specified port was already taken, we can specify another configuration option called restrict port with the value true. And now if we're gonna launch one instance of the development server, and then we'll try to launch another instance, in this case, instead of picking up port which is available, it will throw an error, cause port 3333 is already in use. Another option called headers allows us to specify custom headers for Vite responses. As an example, let's specify one header with a name A and the value B. And then in the browser, if we'll inspect the request for fetching the current page, in here under the response headers, we are noticing our custom header A. And this header will be added not only in the response for fetching the current page, but also for fetching other assets such as JavaScript files. Another interesting option is called proxy, and what this will allow us to do is to provide custom URLs which will be accessible from our dev server. For example, I want to use URL/products to fetch list of dummy products during development, and we can achieve this by specifying custom option proxy. this option holds an object where keys are addresses that would like to be accessible, and the values for those keys will be addresses that the Vite is going to redirect those requests. So for this particular example, I'm going to use third-party servers called dummy JSON, which provides us with dummy API. It basically gives us a set of dummy endpoints, which we can use during our local development. So in this case, I have used the first endpoint products. And now while accessing this endpoint products from our local dev server, I'm supposed to get list of fetched products received from dummy JSON API. That's exactly what we're seeing. But also, besides specifying only addresses for keys inside a proxy object, we can also provide more detailed configuration in the form of object. So for example, I want to have an API route in my development server, which is going to redirect me to that same dummy JSON service. But while redirecting me to this service, I don't want to include API segment in the address. So I'm basically going to modify the final URL which is going to be used to make a request to dummy JSON API by completely removing API segment from the URL, like so. And this configuration is going to allow me to do the following type of requests. For example, if I'm going to refer to /API/products, since API segment will be removed, the resulting URL will be as follows. So only products segment will be added to the end of the dummy.json.com domain. So now let's try to call this URL in the browser, /API/products. This time I'm receiving an error with an error code of 500. This error has something to do with different origins. So without getting too far off the topic, Vite documentation suggests us to use another option, change origin with the value true, to avoid errors related to different origins. So now if I'm going to make that same request on API/products, I'm receiving the list of products. But this time we can do even more. For example, let's use different URL. Let's try to fetch a list of posts by using post URL. And to do this, I simply have to change this segment on posts, like so. As we can see, it has worked, and we got a list of posts in the response. So for now, we were only specifying all configurations for the server under the server key in the configuration file. But we can also assign separate configurations for the preview server. So let's build this project for production by running npm run build, and then run preview server by executing npm run preview. As we can see, the default port of the preview server is 4173. Let's just try to override some configurations for the preview server. For that, I'm going to copy over this object, paste it down here, and rename option server on preview. And this configuration will only be applicable for the preview server. Let's change something in this configuration. For example, let's use different port, remove this headers object, and add another option called open. Here we can specify which address should be open in a browser by default after starting preview server. I'm going to specify our custom URL API/products. And just because we have previously configured proxy, a request was made to the following URL API/products, and we get the list of products on the page. And this is how we can override configurations for the preview server as well as for the development server. In fact, there are many more configurations for configuring servers, and all of them are described in details in the official Vite documentation. In one of the previous lessons, we have implemented the custom Vite plugin, which allows us to import CSV files inside JavaScript modules. Inside of our main JavaScript file, we are importing the file products.csv, and then raw content of the CSV file will be transformed by our plugin and turned into array of JavaScript objects. And from the code point of view, it looks like this. Inside of Vite configuration file, we are including this plugin by calling factory function CSV, which we are importing from Vite plugin CSV file. Let's open up this file and take a look at the implementation. So here we're basically using the hook called transform, which will be called by Vite anytime we are going to import CSV files in ECMAScript modules. And then we're basically converting the raw content of the CSV file into valid JavaScript array of objects by using this function parse. And at the end, we are returning valid ECMAScript module to the client, which contains the data from the CSV file in the form of array of JavaScript objects. And here's how our products.csv file currently looks like that we are importing in our main JavaScript file right here. And then we're basically injecting the content that we have received after importing that CSV file into the pre-tag, and which is why we're seeing the content of the CSV file on this page. But the thing is that now, if we're going to update the content of the CSV file, it will cause the full page refresh of the browser. And just to see it in action, let's create arbitrary constant plugin and see if this plugin constant will still be available after we're gonna modify CSV file. Let's just go ahead and make any modification to the content of the products.csv file. I'm basically gonna add another row in here. And then in the browser, let's see if the plugin constant is still available. So first of all, we're seeing here that the new line that was added in the CSV file was appeared on this page, but the plugin constant is undefined because browser has made full page refresh in order to update the content on the page. So now we're going to implement support of so-called hot module replacement for our plugin. And this technique basically allows us to update modules that are modified without doing the full page refresh in the browser. It's called HMR, which stands for hot module replacement. And in order to implement hot module replacement for our plugin, we need to use another hook provided by Vite called handle hot update. This hook is going to do a synchronous operation, so let's mark this function as an async function. And as a first parameter into this function, Vite will pass context object. So this function will be called anytime we're going to modify any module that we are currently importing in our JavaScript files. But we don't need to listen for all updates, but only for updates that happen to .csv files. So let's use the same condition we have used in the transform hook and check if modification has been done to .csv file. Only then we're gonna run this logic inside this if conditional. But here, in order to access the file name which was updated, we need to reference property file on this context object. And the way we're gonna implement hot module replacement is by leveraging WebSocket connection and firing custom event to the client by using method send on the WebSocket object like this. And then we also have to specify custom configuration for this event. Let's specify the type, which will be a custom. The event name will be CSV-update. Here we can use any kind of name we like. Later we're gonna listen to this event in the client code. And then we also have to specify the data key. And this key will basically store the content which we're going to send to the client. For now, let's just read the content of the updated CSV file by calling method read on the context object. And since this method is asynchronous, we have to await the response and then assign it to the data property like so. And right after that, just to tell Vite that we are going to take care about hot module replacement ourselves, we need to notify Vite about it by simply returning an empty array from this method like this. So now let's try it out one more time and check if the constant that we're going to declare in here will be available even after we're gonna modify .csv file. So I'm going to remove the last line of the CSV file and check if the plugin constant is still available. So as we can see, it is still defined. That means the browser hasn't reloaded the page. But we also haven't seen any changes to the content on the page because we are currently not listening to the custom event that we are firing from the server. So this was the first part of implementing the hot module replacement, which is firing an event from the server to the client. The next part is to actually listen for this event on the client side. So I'm gonna switch over to the client script. And in here, first of all, let's check if the object which is responsible for hot module replacement exists. This object is stored on the meta property of an import object. And if so, we're going to register a listener for the custom event we have specified on the server with the name CSV update. And as a second argument to this function, we have to pass closure with one parameter. And this parameter is basically going to store the data that we have specified under the data key while sending this event right here. So first of all, let's check it out what we're going to receive in this data parameter. I'm going to print it out in a console. Let's switch over to the browser. As we can see, currently I have 3 products in my .csv file. Let's go there and change the content. And after that, in the browser, we can see that the console shows new content of the CSV file, including our latest product addition. So now we're gonna get to updates on the actual page, because after CSV file is modified, we need to properly change the content on the page. To do so, in our client script, I'm going to copy this line and paste it into this handler. So anytime we're gonna receive the new content from the server, we're going to update the content of the pre tag by assigning updated content. But currently this content will be passed as a raw content of the CSV file. But what we need to do instead in our plugin is to actually transform CSV content into JavaScript array by calling function parse, just like we have done in this transform hook. So let's wrap the content of the CSV file in the parse function call, and this way client application will receive JavaScript array instead of a raw CSV content. So now back to the browser and check it out once again. Initially I have 4 products in my CSV file. Let's remove the last product from here and see how it will be reflected in the browser. As we can see, content was changed, and now instead of 4 products, I have only 3, which corresponds to the latest content of the CSV file. And that means that our hot module replacement worked. And from the server via WebSocket connection, we have received updated content of the CSV file in the form of array of objects. And of course now, as soon as I'm gonna do any kind of modifications to the CSV file, instantly I'm going to see those changes reflected on the page. So as we can see, our first product was back. And now let's just do one little improvement to our plugin by passing structured data to the client. So I'm going to send an object with 2 properties. First property will be a URL, and second one data. URL will store the path to the module that was updated, and the data will store the new transformed content of the updated module. Let's just add more descriptive message on the client side in the console and say which module was updated. And here we have to destructure 2 properties, URL and the data. Those are 2 properties we have just specified in the source code of our plugin right here. So now let's check it out one more time in a browser. We'll create constant plugin, and if this constant will be available, this will be a sign that the browser hasn't done full page refresh. So after modifying the content of the products.csv file, we can see that it was reflected on the page, as well as we can see the new log, which shows the path to the file which was updated. And of course, the constant plugin is still available. So our hot module replacement for CSV files works great. And this is how we can implement hot module replacement in Vite projects, by basically using the function handleHotUpdate in our plugin, and then sending custom event via WebSocket to the client with appropriate payload. And then on the client side, we are registering the listener for this event, accept updated data, and then do whatever we need with this updated data in order to apply hot module replacement update. So this was one of the ways how we can implement hot module replacement in Vite. Now let's see how Vite allows us to establish client-server communication. Just like in the previous lesson when we were using hook handleHotUpdate to implement hot module replacement feature for our plugin. And in here we were using WebSocket object to send events to the client. And then we also had a chance to specify which data exactly should be sent along with this event. And in our client script, we have registered listener for this event, accepted the data received from the server, And then we were able to do anything we want with this data to implement hot module replacement. But besides using this hook handle hot update, which will be called only when any module that we are importing in JavaScript files will be changed, we can use another hook which allows us to configure the server, and this hook is called configure server, which accepts a server instance as the first parameter. And by using this server object, we can also access WebSocket connection. So just like previously, we can set up a listener for all kinds of events. For example, there is a default event called connection, which will be fired whenever our WebSocket connection will be established. So we can try listening for this event in here, and once we establish WebSocket connection, let's send an event to the client with the name connected. And as a payload, we can send simple message, connection established. And now to be able to listen for this event from the client code, we have to register a listener by using object hot. So here we also call the method called on, and as a first parameter we have to specify event name, which will be listening for, and as a second parameter we specify the closure, which will be our event handler. So this closure is going to receive the payload sent from the server along with this event. And now let's see what will be printed in a console. I'm going to switch over to the browser, and as we can see in here we have that message sent from the server once WebSocket connection was established. And this way we can exchange messages between server and the client. For example, let's fire another event as a response to the server with a name ping, and the payload, which will also be a simple message, hello server. And now going back to our plugin implementation, inside of this configure server hook, let's register another listener for the ping event and specify an event handler. This time, event handler is going to receive two parameters, first of which will be the payload sent from the client, and the second parameter will be the client itself. In other words, the object that represents the connection. And inside of this closure, we will be able to use this object to send events to the client. So as a response, let's send event with a name pong and the message hello client. And now one more time, let's switch over to our client script and register a listener for this event pong by using that same object hot. As an event handler, let's specify the closure, which will receive the payload as the first argument, and print this payload in a console. So now in the browser console we can see two messages. The first one was printed once WebSocket connection was established, because previously on the server side in our plugin implementation code we have registered listener for the connection event, and as soon as WebSocket connection was established, we send the event called connected to the server with the message connection established, and then client has received this event and printed that message in a console. And now to reply back to the server, client sent another event with a name ping and the message hello server. On the server side we have registered a listener for the event ping and also printed the message which will come from the client in the server console. So now if we're going to take a look on the server console, we're going to see here that message received from the client hello server. And finally, besides printing this message in a console, we're also firing another event pong to the client with the message hello client. And in our client script, we're basically listening for this event and printing received message in the browser console, and which is why we're seeing in here a second log that says hello client received from the server. And by the way, all those listeners and events which we have used in here, this call will be executed only if an object hot will be available, because we have wrapped everything in the if conditional. And the thing is that this object hot will be available only during development. So if we're going to build this project for production by running npm run build, this object hot will not be available. So all this code will be basically removed from the production bundle by using tree shaking. So at the end, let's just make sure that this is the case. I'm going to print out simple message in here just to see that this code will be executed. And indeed, we're seeing that log hot in the browser console along with other logs. Because currently I'm running development server, but once I'm going to switch over to the console and run the command to build this project for production, and then run production build in the browser by executing npm run preview, sure enough, I'm not going to see any logs whatsoever. This is because that conditional block which we're checking if hot object is present has not been executed, since hot object is not available in the production build. So this is how we can exchange messages between our plugins and the client code by using WebSocket connection provided by Vite. In one of the previous lessons we have implemented hot module replacement for CSV modules. The way we have done this is by using handle hot update hook inside of our plugin implementation. So in here, whenever .csv file will be modified, we would fire event via WebSocket connection to the client and include all necessary data along with this event so that client could receive this data and then implement all necessary updates. And in this lesson, we're going to see how we can implement hot module replacement for JavaScript files. So I'm going to comment out all these listeners. We're not gonna need them in this lesson. And also we don't need to fire any custom events from our server. So let's just comment out this hook, configure server, which was basically used to fire custom events via WebSocket connection to the client. And before getting to implementing hot module replacement for JavaScript files, let's do a little preparation. I'm going to create new JavaScript module in the root of the project. Let's call this file module.js. And here, let's add some dummy code. For example, let's export constant with the name message and the random string. And also let's add one more export, which will be a default export, also with a random string. And now we're going to use HMR API to implement hot module replacement. And all the code which we will need for hot module replacement, we're gonna wrap in the if conditional and check if hot object is present. Then we're gonna implement HMR so that Vite could properly remove this code when doing production builds, since we don't need to provide HMR during production. So in order to implement hot module replacement for this specific module, we can leverage method called accept on the object hot. So this method accepts closure, which in turn accepts one parameter, which will be updated content of this module. Let's call this parameter updated module, and then print out this variable in the browser console. And just to see it in action, we of course have to go back to our main JavaScript file and write an import statement to import our new module. And regarding all other code, we actually don't need any of that, so let's comment everything out, besides our import. And one more thing before we'll check it in a browser, let's go back to module.js and print something out so we can see that this module will be loaded. And here we go, we got that log, that means that our module was properly included. And now let's see what is going to happen as soon as I'm going to modify the file module.js. For example, let's change this string, and in the browser console, I'm seeing a different log, which was just modified because after updating this file, this module was executed again. And then we also got this log, which contains updated content of this module in the form of an object. So here we can see a default export of this module, as well as a named export of the constant message. And this log was printed by using this closure that we have passed into accept method. So now if I'm going to modify the value of the message constant, for example, right away I'm seeing the new log in the browser, and this time the constant message contains the new value that we have just updated. So anytime we're going to modify module.js file, we're going to see here new log with updated content of that file. And by the way, all this is happening without full page refreshes. But what if I'm not going to use call accept in this module? Let's test it out. Let's comment out this part. In the browser, I'm only seeing one log, which was printed on the initial page load. But after I'm going to modify the file module.js, in the console, we can see only the new log without all previous outputs. And that is because browser has made full page refresh. So in this case, there is no hot module replacement. And again, if I'm gonna go back to the editor and comment this code back in, then initially here I'm seeing only one log from the module.js. And after I'm going to modify this log, we're still going to see the old log as well as the new output. And in addition to that, we got an object which contains updated data of the module. So in this case, as I'm using accept method in my module, anytime we're modifying module.js, browser is not going to make full page refresh in order to update this module in a browser, because all these updates are happening by using hot module replacement technique. And now let's consider another example. So what if my module.js is going to import another module? Let's emulate this situation. Let's create a new file and call it submodule.js. This module is going to have only one default export of the random string. And then we're going to import this module from within module.js right here. And now let's say we want to monitor changes in all those modules we are importing in this module. So for example, I want to run some code anytime the module submodule.js will change. So in here, I'm going to use another code to method accept, which in this case will have a different shape. As the first parameter, we can provide an array which consists of all those imports we'd like to monitor changes in. So for example, in here, I'm going to watch file called submodule.js. So I'm going to include this name in here. And then in this closure, we're going to receive an updated content of every module that we are monitoring. Since in this case, I'm monitoring only one module, I'm going to destructure this parameter and extract only the content of this submodule file. And eventually, let's see what will be contained in this new submodule variable, which is supposed to give us updated content of the submodule file. And before checking it out in the browser, I'm going to include console log statement inside submodule.js for testing purposes. So on the initial page load, we can see two logs obtained from loading submodule.js as well as module.js. And now let's see what is going to happen if I'm going to modify the content of the submodule.js. Let's change this message. Go back to the browser. And here I can see the log from submodule.js again, because after modifying this file, it was executed in the browser one more time. And then I'm seeing another log, which contains updated content of the modified submodule.js file. And that is because in our parent module, which is called module.js, we have registered this listener, which monitors for changes inside submodule.js file. And when the change occurs, it is going to print the updated data of this submodule in the form of an object. And if I'm going to make mistake in the submodule name, and then we'll do any modifications to this submodule, then in the browser, I'm still going to see the log, but this log comes from a different place. It is actually this part of code which prints that log entry. So just to make it all clear, let's comment out this part and modify submodule.js once again. And as we can see after modification, there are no extra logs in the console, because we are no longer listening for changes in the submodule. So let's go back to module.js and fix that mistake in this name submodule.js. And one more time, if I'm gonna go ahead and modify the file submodule.js, sure enough in the console, we're going to see a new log entry with an updated content of the submodule file. And by the way, if we're going to make any syntax errors in our modules, then that log which is responsible for showing updated content of the module will print value undefined instead. So if we're planning to use this value in our closure, it's necessary to firstly check if the received value actually exists. So we're going to wrap this part in the if conditional. So now if we're going to make any syntax errors in our modules, it will prevent us from potential crashes. And it's actually good to do these kind of checks most of the times, So let's add the same conditional to this closure. Let's keep learning Vite in the next lesson. So by now we already know how we can accept HMR updates by using method accept and apply them to our page. And this method accept has a few signatures. First one allows us to accept updates of the model itself, and the other signature allows us to accept updates from dependencies of this module. In other words, from those modules that are imported in this module, like we're doing in here, where we are monitoring changes inside of submodule.js. But there can be such situations where when modules are updated and updates are applied in a browser, those updates might also leave some kind of side effects. For example, those updates might modify DOM structure or change some data in local storage of the browser. Or even a simple console log statement can also be considered a side effect. And sometimes before applying updates of the module in a browser, we need to run some kind of a code which would clean up those side effects left from previous executions of this module. It might sound complicated, but in fact, it is really simple. Let's consider one example. I'm going to create variable styles, and then let's declare the function addStyleSheet, which is basically going to add styles into head element on the page. So in here, I'm going to use DOM API to create DOM element which corresponds to the style tag. And then we're going to assign arbitrary styles to the inner HTML property. For example, let's make background color of the body indigo and text color will be white. And then all we have to do is to append this style element to the head element, like so, by using method appendChild. And of course, to apply these changes, we have to execute this function once current module will be loaded in the browser. So let's call the function addStyleSheet right here. And also let's open up index.html, and in here we'll add h1 element. So in the browser we see that those styles were applied, and if we take a look at the head element, at the end we can see that style element that we have just added. So far it looks good, but what is going to happen if we're going to modify the styles in any way? For example, let's change the color on yellow and take a look in the browser. The color was properly applied to the page by using hot module replacement, but in fact if we take a look at the DOM structure, here we have two style elements. So the previous style element was not removed, and the new one was just added. So the previous execution of this module has left side effect in the DOM by adding style element, but right after we have updated those styles, the previous style tag was not removed. So it produced so-called side effect, but we didn't clean up that side effect before applying new updates and inserting new style element. And as you may have guessed, anytime we're going to do any kind of changes to our module, we're going to get the new style element appended to head element. So now let's see how we can actually clean up after ourselves. And anytime we're going to modify this module, the previous style tag will be removed and the new one will be appended. And for that, let's create new function, call it remove style sheet. And all this function is going to do is basically remove styles DOM element by calling remove method like this. But the question is, where do we actually need to call this function remove style sheet? And since this function has to be executed right before we're going to receive new HMR updates, Vite provides us with another method called dispose that we also call on the hot object. And the closure, which will be passed into this method, should execute all necessary cleanup code to get rid of previous side effects. So this is exactly the place where we can call our function remove style sheet to remove style DOM element. So now before going back to the browser, let's actually reset these styles as they were initially. Let's also do a full page refresh to have only one style element on the page. So now after I'm going to modify this module, in the browser what we will actually see is that before appending updated styles onto the page, the previous style element was removed, because that function remove style sheet was executed inside of a closure of the method dispose, which cleaned up our previous side effect before appending new element. And just to see at what time those functions are executed, let's just place arbitrary console log statement into function addStyleSheet as well as removeStyleSheet. So on the initial page load, our module was executed and called function addStyleSheet, and therefore new styles were applied to the page. And after any subsequent modifications of this module, we're going to see that before applying new updates, our function removeStyleSheet was executed thanks to that method dispose that we have called on the hot object. So the previous styles were removed, and then the new styles were added. And this way we end up only with one style element on the page. Let's go back to the editor and remove these two console log statements. So by now we know how we can accept hot module updates by using method accept, as well as how to remove any side effects before applying new updates by using function dispose. And now a couple of words about standard Vite events that we can listen to. And there are several events that we can listen to, and all of them are shown on this documentation page. So for demonstration purposes, let's just register listeners for some of these events. As the first parameter, we have to specify an event name. I'm going to use before update event. And as a second parameter, we're passing the handler, which is going to take some data received from the server. Let's just print out this data in the console, and then duplicate this piece of code a couple more times to register listeners for other events, such as for after update and for the error event, like this. And just to make it clear which console log statement corresponds to which listener, I'm going to add in here labels: before update, after update, and error. So again, initially there are no logs that came from those listeners because none of those events were fired on the initial page load, because they will be fired once we're gonna modify the module. So let's do just that. I'm gonna go ahead and change the color of the background. And then in a browser, we can see that firstly we have received the log which came from the before update event listener with some metadata about the module which was updated, when it was updated, and the path to this module. So this log was printed right before we have applied HMR update, and the after update log was printed after we have applied HMR updates, and this event handler also received the same object which describes the module which was updated. And just to trigger the error event, we have to make syntax error in this module, and then in the console we're gonna see that the error was printed, which means the error handler was executed. And the data that we have received in here contains the full description of the error. And by the way, the same error was displayed right here. And this is how we can leverage those default events to be able to hook into HMR process and execute particular code at the different stages of HMR updates. In this lesson, we're going to take a look at how we can integrate framework view in Vite project. So I have already scaffolded default Vite project. So let's start development server by running npm run dev. And by the way, while scaffolding new Vite project, there is a special command that we can use, which will basically scaffold Vite project with Vue framework already integrated. But just to better understand this whole process and to see what is going on under the hood, we're going to do this manually. And the first thing we need to do is, of course, install all necessary npm dependencies, such as framework Vue itself and Vite plugin, which will allow us to convert files with an extension .vue into JavaScript code. So after installing both of these dependencies, we need to open up Vite configuration file, vite.config.js, and in here we have to include that plugin we have just installed, plugin Vue, into this array by calling this function Vue. And then let's just remove everything from the main.js file and start writing Vue component. So inside of our index.html file, we already have an element with an ID of app. This will be an element where we're going to mount our Vue application. So firstly, we're going to create the root component, app.vue, and for demonstration purposes, we're going to use a very basic example of a counter component. So I'm going to create here one reactive variable by running function ref. This variable is going to store current value of our counter. And inside the template of this component, let's add h1 element with a text counter. And right under, we're going to add a button which will allow us to increment count variable. So let's also output the value of the count variable in here and register click listener on this button, which will basically increment count variable like this. So now that we have one Vue component, we need to initialize Vue application in our main script. So in here, firstly, let's import our root component from the file app.vue, and also we'll need to import function createApp from the Vue package, which is going to be used to initialize our Vue application. And in here, let's call this function createApp, passing our root component, and then calling function mount and specifying an identifier of that element where we're going to mount our application into. And just as a reminder, we already have an element with an ID of app in our index.html. So now in the browser, as we can see, we have a working counter, so our Vue application was properly initialized. And now let's take a look at the transformation which Vite has applied to our app component. I have additionally installed plugin called Vite plugin inspect in order to see what transformation Vite applies to our modules. So we can open up this URL in the browser, and in here we're going to see all those transformations done to our modules. So whenever we are importing app.vue component, Vite plugin is going to take the content of this component and turn all this content into valid JavaScript code. In other words, into the render function, which will be called on the client side and render our component on the page. And now let's also take a look on the network tab. So when browser fetches main.js, then it fires a call to the server to fetch the content of the app.vue component. But instead of giving us the raw content of the app.vue component, Vite has applied the plugin to the file with this .vue extension, which would transform Vue template into valid JavaScript syntax. And this is the code which is responsible for rendering counter component on the page. So as we can see, it was very easy to integrate Vue framework into Vite project. Initially, we just had to install 2 npm dependencies, Vue framework itself, and Vite plugin to transform .vue files into JavaScript code. And then we had to include this plugin inside of Vite configuration file, just like any other Vite plugin. And after doing all these steps, we have actually provided the full support of the Vue framework inside Vite project. So we can develop Vue application in a normal way by creating components with .vue extensions, importing those components. They will be properly transformed into valid JavaScript code, and everything will be working fine. And this is how we integrate Vue framework in Vite projects. In this lesson, we're going to take a look at how we can integrate React into Vite project. So I have prepared an empty Vite project, which doesn't use any frameworks. So let's get to integrating React. And actually, before we start, there is an option which Vite provides us with, which allows us to scaffold Vite project with React integrated right from the beginning. And for that, we just need to use value React for this template option and run the following command. But just to better understand this whole process and how the integration happens, we're going to do all these steps manually. And before we start, we actually have to install all necessary npm packages, such as libraries React, React DOM, and Vite plugin, which allows us to import React components. And after all those libraries are installed, we have to open up configuration file, vite.config.js, and in here let's import the plugin from the vitejs plugin React package. And then to include this plugin, we have to call this function React in this array of plugins, like so. And that's basically it. Now we can just start developing React application. So everything starts with the main script file, main.js. Let's remove everything from this file and also rename this file on main.jsx, since we're gonna use JSX syntax in this file. And also we have to fix the path to this file inside of index.html. So let's go here and fix this extension right here. As we can see, we already have a div with an identifier up. This will be a div where we're going to mount React application. So let's create our root component. We'll call the new file app.jsx, and here we're going to use a simple example, which will be basic counter component. So let's import useState function from React. Then we're also going to create file with styles and import them right here. And then down here, let's define our component function app. So this function is going to have only one state variable, which will be a counter. Initial value for this counter will be 0. And right here, let's define our template for this component. So I'm going to add h1 element with the counter text. And down below, we're going to create the button, which is going to increment our counter. And just to see if our counter gets incremented, we're also going to show this variable's value as the label for this button, like so. And now we'll register the listener, which will be fired when clicking on this button. And inside of this listener, we're basically going to update state variable count by incrementing it by 1. And finally, at the bottom of this file, let's export this component as a default export. And also just to check if we will be able to import CSS files with styles, and those styles will be applied to our components, let's create basic CSS file with the name app.css. And in here I'm going to describe one rule for the h1 element and make the color of this element blue, because previously I have already imported this CSS file in our component, which is supposed to make this h1 element blue. So now that we have our root component in place, we actually have to initialize React application inside of our main script. So in here we're going to import React DOM library from the React DOM client. And also we're gonna import our root component up from app.jsx. In here we have to pass DOM element where we're going to mount our application into. In this case, we're going to mount it inside of element with an ID of app. And eventually, to render this application, we're calling method render. And as the parameter, we're specifying our root component as a JSX. And after that, if we're gonna take a look in a browser, sure enough, we're gonna see working counter. And that means that React application was properly initialized. So now just to see what transformations are being applied to our React components, we can use plugin inspect, which I have already pre-installed, which allows us to open up this URL in a browser and see transformations that happen to our imports. So in this case, once browser reads main.jsx file, then it sees this import of app.jsx component, then it fires the call to the server to fetch the code of this component. And instead of giving us the raw content of this component, Vite applies React plugin to convert the content of this component into a render function, which will be recognized in the browser. And then this function runs in the browser, and this way we're seeing our counter component on the page. And if we open up our inspector and take a look at the transformation which is happening with our component file, we're gonna see that this JSX syntax was converted into proper render function, which will be recognized and run in the browser. And this is it. The whole process of React integration into Vite project was pretty simple. So just to recap, we had to install 3 dependencies: React, React DOM, and plugin for React. And then we had to include this plugin inside Vite configuration file in this plugins array. And this is what actually allows us to create and import React components in our files. So we can start developing our React applications in Vite projects as we are used to. We are slowly approaching the end of the course, and in this final lesson we're going to take a look how to deploy Vite application. And the service for the deployment that we are going to be using is called GitHub Pages. In fact, there are a lot more services Vite provides support for when it comes to deployment. And the deployment process is pretty simple for any of those services. So we're going to review deployment steps by using GitHub Pages. As always, I have already prepared default Vite application, which we're going to deploy. And actually, before getting to the deployment, we need to make sure that our repository exists on GitHub, which in my case it does, so we can go directly to the deployment. We will not change any default configurations, so after building our project, all build files will be located inside this folder. And this is exactly the folder which is going to be deployed. So here in docs, let's choose the option deployment to GitHub Pages, and our repository URL corresponds to this format, where we have two URL segments. First one is our GitHub username, and the second one is the name of the repository. So the only configuration option we have to specify will be the option called base, and this option should contain the name of our repository. So let's just go ahead and create configuration file vite.config.js in the root of this project. From here we're going to export configuration object with only one option, base, where we're gonna specify repository name, which in my case is vite-deployment. And once again, this is really important that this option value should match repository name on GitHub. So now we have to create new commit where we're gonna include our configuration file. Let's specify any message and push this commit to GitHub. After that, let's just make sure that the new commit appears in the GitHub history of our project. It is this second commit. Then let's open up Settings tab. The main branch of our repository is main, so we're gonna deploy this branch. And now on the left side, let's open up page called Pages. And in here we have to set up some deployment configurations. Firstly, in this source dropdown, we have to choose option GitHub Actions. And then let's click this link, create your own, which is basically going to create an empty deployment configuration file. Let's clear out all this predefined content and specify our own configurations. And these configurations are listed in Vite docs. So we just have to copy over this whole configuration, paste it in that file, and let's quickly go through some of the options specified in this file. In here we can see which branch is going to be deployed, and down here there are a couple of steps which will be executed during deployment. For example, in here we can see that the node version which is going to be used to build our project will be version 18. Then we're gonna install all npm dependencies by running npm install. After that, we're gonna build the project by running npm run build. And at the end, once this folder with our build files will be created, this folder will be deployed to GitHub Pages server. Then let's just give this configuration file a name, for example deploy.yml, and click Commit Changes. In here, let's make sure that the new commit will be created on the main branch. Let's click Commit Changes once again. And then we can see another new commit in the commit history. That's the commit with the configuration file for deployment we have just created. And then if we open up tab Actions, here we can actually see the new deployment task that is currently running. And this is our deployment task. So anytime we're gonna push changes to the main branch, it will automatically kick off the deployment process. And by clicking on this task, we can actually inspect what steps are executed during the deployment. And once this deployment will be successfully finished, we can once again open up Settings tab and then go to Pages page. And in here, we will see the URL where our application will be available on the web. So by following this URL, we can see that our application was successfully deployed on GitHub pages. And that's it, we were able to successfully deploy Vite application on GitHub pages server. As we can see, it was pretty simple process. And if we decide to deploy our project by using another hosting provider, the deployment process is going to be pretty simple as well. And with that, we're finishing this course about Vite Bundler.